Hello, welcome to this series on digital technologies and the future of manufacturing. My name is MS Krishnan, and I'm the Accenture Professor of Computer and Information Systems at the Ross Business School, University of Michigan. My research interests in the last 25 years have been in the intersection of digital technologies and business. We have organized this course for all of you to build awareness and knowledge about how digital technologies are fundamentally reshaping the state of manufacturing. I believe that some of the emerging trends in digital technologies will redefine how we understand manufacturing and also redefine the skills that are required in manufacturing. I also believe that these changes will lead to new business trade-offs and social impacts. I look forward to engaging with all of you in this course. The learning objectives for us in this course includes the following technologies: sensor technologies, industrial Internet of Things; digital twins technology and how it affects manufacturing, how is it used in manufacturing; additive manufacturing or 3D printing as we know it; and also the social and business implications of these technologies. I'd like to emphasize that our focus in this course is not about the technical aspects of these technologies. We are not going to be getting into the nitty-gritties of how this technology works, neither are we going to be giving hands-on experience to learners on how to use these technologies. That's not the purpose of this course. The purpose of this course is to focus on the business aspect of these technologies. So specifically, in each of these individual technology, our learning objectives have been organized in a framework to address the following questions. We look at what this technology is about and how it works. We look at the successful implementation of these technologies. While many organizations invest in these technologies, only few are successful in solving business problems and showing business value from these technologies. We'll try to understand why that happens and what leads to success. We will also understand specific examples from real-world cases, and we'll understand the business value benefits and business advantages coming from these technology capabilities. We'll also dwell into the risks and challenges, because all these technologies, while they bring a lot of benefits, they also do bring some risks. It is important to understand what those risks are and how do we manage and counter them. And finally, in each of these technologies, we'll have a section talking about the future trends in these technologies in the next 3 to 5 years. Our learning mechanism, Learning Together, will include video lectures, as you're seeing now. We have industry experts from several organizations across the globe coming in, sharing their insights, their learning experience in this course. Then we'll be able to look at and listen to those conversations and reflect upon them. And we'll also bring some case studies. Before we talk about the future of manufacturing, let's look at the past and in the history of where we are coming from. In fact, if you look at manufacturing before 2015 or so, roughly around that time, it is often called, what we say, Industry 3.0, this state of manufacturing at the time. And if you look at, Industry 3.0 is all about automation at a unit level, a lot of focus on continuous improvement of processes, lean process techniques, and lean process management, and focusing on productivity, quality, and of course, there was some digitization. Now, if you look at on this slide, what we have on the left-hand side is the Industry 3.0 before 2015 or a few years before that. But what you see on the right-hand side is the more popular term often used now called Industry 4.0. Industry 4.0 is the digital transformation of the Rust Belt manufacturing industries to smart factories using some of the emerging digital technologies that we will be talking about in this course. Now, some of these technologies are bringing new levels of transparency, new levels of connectivity, and new intelligence, both machine and human intelligence, working together, and hence allowing manufacturers to completely reimagine their processes end to end, starting from supplier engagement on one side and up to customer connection on the other. So the entire process of manufacturing can be reimagined because of the capabilities that are coming with these technologies. Now, let's look at technologies of digitalization of manufacturing. Now, automation in manufacturing is not new. In fact, if you look at this picture in the slide, and if you had visited, recent, a manufacturing facility, maybe even say 10 or 15 years back, maybe relatively modern manufacturing organization, shop floor, you certainly would have seen robots like this. Because my point is, robots in manufacturing has been there for many years. They aren't new. And so that kind of an automation has been there in manufacturing, to replace specifically tasks that has been difficult to do for humans. Digitization has also been there in the process and various other ways in manufacturing for many years now. For example, computer-aided design or CAD has been used by manufacturers for more than 20 years now, where they capture the digital information of the every part that goes into the product, and they actually organize and optimize the design and put it together. And all those pieces have been captured in the CAD, computer-aided design, and also to some extent computer-aided manufacturing. The software called product life cycle management software, PLM software, allows for manufacturers to digitize the entire new product development process. And that has been in use almost for 15, 20 years or gain, right? We all know about the ERP, or the enterprise resource planning software, which digitizes the business processes of manufacturing, starting from operations, finance, HR, and you name it. So this actually brings together the entire business process network inside the manufacturing organization in this software. In addition to this, manufacturers also used what I call as the programmable logic controllers, and this has been in use for many years now, where you're able to program the behavior of a particular machine depending upon specific inputs and the logic in it. And basically, these programmable logic controllers bring in a new level of flexibility for manufacturers to use a machine in different contexts. So these technologies have been there in manufacturing. I mean, digitization is not that new. So what is new? And why this, Industry 4.0, a lot of hype about this Industry 4.0 concept? Well, I believe that there are about 6 major technology trends that we have seen in the last decade or so. As they are coming together, I believe they are going to fundamentally transform every aspect of business, and also specifically in the manufacturing industry. I'll first start with the ubiquitous connectivity. For the first time in the human world, we are able to connect billions of people across the globe, through high-speed connectivity. And these people, they could be in developing world, developed world, and you name it, right? And that has profound implications, because when people are connected, then they are more informed. When consumers are more informed, they better understand. They start to understand their needs, in a different way. And that starts to begin some implications for manufacturing. The second, pervasive digitization. Now, by pervasive digitization, I don't just mean the automation of process with digital technology, but more interestingly, the embedded intelligence that is coming into both product and processes. And this pervasive digitization of product and process now is enabling manufacturers to connect with consumers in multiple ways through their products or processes. Third, the emergence of cloud computing. The access to high-speed computing was a privilege only for manufacturers with deep pockets. However, the advent of cloud computing has pulled this entire computing capability into central cloud, both the logic and data, and allowing access, ubiquitous access from anywhere you are, and both to large companies and small manufacturers, and hence democratizing the access to this capability. Next, the advent of big data analytics. These technologies are bringing, real-time data, in enormous volume. And at the same time, the advent of both machine intelligence and human intelligence to come together to solve problems, I think that is new and bringing new capabilities for manufacturing. Next, the advent of social media is again, bringing for the first time in history a platform where consumers and citizens can connect on a single platform across the globe. And this is allowing consumers to learn from each other and and learn new concepts. And also, these platforms are allowing manufacturing firms to learn more about their consumers, consumer behaviors, wants, etc. Last but not the least, the emergence of smart sensor networks. Now, there's been a significant advances in sensor technologies in the last 2 decades. The costs significantly have come down, and hence these smart sensor networks are now offering new capabilities for manufacturers to build new levels of visibility and build new logic for different behaviors in the processes. And that is allowing to reimagining processes that was traditionally well understood in manufacturing. And these processes, reimagination of these processes is going to bring completely new value proposition, but for all the stakeholders in manufacturing. So in summary, if I put all these 6 trends together, I believe that we are fundamentally changing the big shift. We're seeing a big shift in terms of how we understand manufacturing, how we automate manufacturing, and how we manage manufacturing. In fact, the shift is going to be what we talked about in Industry 3.0, where the focus was a lot on unit level optimization and unit level automation, and also focus on more processes and process improvement, way of solving problems, and that is more continuous improvement based. Two, what I see in what I show on the right hand side of the slide is, a new way of capturing real-time information from every aspect of the manufacturing process end to end, so that you can, through sensors and through various other technologies and connectivity, you can bring the full visibility, virtual visibility of the manufacturing operations in a central war room, and where managers, he or she can manage this process sitting in this room and tracking the live operation of every process, every asset, and every moment within the manufacturing plant. Interestingly, if you add cloud computing, as we talked about, as one of the tech trends, now this entire capability that you see in a centralized war room in a large manufacturing facility, this entire data can now come back into the manager wherever he or she is. The manager she could be sitting at her home, but she could actually get access to the entire monitoring of the manufacturing, entire live operations of what's going on in the plant, and she can take decisions, she can get insights from the data, and she can, in a way, manage this entire operations remotely. So in summary, what is this shift from Industry 3.0 to Industry 4.0 we are talking about? Well, as you can see in the slide, this shift is away from unit level automation, and it is away from just process-focused approach to solving problems. It is a shift away from focus on incremental continuous improvement. Basically, more and more, Industry 3.0 focus was on incremental changes, incremental improvement on a continuous basis, which is good. But what you see on the right-hand side is the Industry 4.0. Because of these new capabilities coming with these emerging technologies in use, we are able to look at managing the entire manufacturing process, be using real-time data on a common cloud platform, integrated platform, and bring in embedded intelligence both into the product and process, and put all these things together to fundamentally reimagine the processes and not just about continuous improvement. Now, this reimagining of these processes would actually lead to new value creation for across the stakeholders in manufacturing, whether it is suppliers, whether it is employees or consumers. I believe there is a profound change that we are seeing in the manufacturing industry coming from the application of these emerging technologies. Today, we are delighted to have esteemed industry experts and senior executives from Siemens who are multiple decades of experience in championing this digitally enabled change in the manufacturing industry. I'll start first with Rahul Garg.
I'm Rahul Garg. I'm responsible for the global industrial machinery business inside Siemens Digital Industries software, and excited to participate in this discussion.
Thank you, Rahul. Bill?
Yeah, hi, my name is Bill Butcher. I'm the global marketing leader for the industrial machinery team at Siemens as well. Been working in the space for over 20 years, focusing on digital manufacturing, simulation, and data management.
This is Frans Ramic. I'm the Solution Director for Industry Marketing, working closely together with Raul. I've been in the machinery business now for 35 years.
My name is Jim Thompson. I'm the industry leader for the medical device and pharmaceutical industries here at Siemens Digital Industry Software.
My name's Ian Haddon. I'm a Solution Director in the industry team. I've got almost 20 years experience in the PLM and manufacturing space.
Rahul, I would like to first start with you based on your rich experience and also the experience that Siemens, has had, working with the manufacturing industry, shaping the technologies and the platforms that are used. If I ask you to comment, how is this digital technology revolution? How is it changing manufacturing, and what are the new kinds of trends that you're seeing?
So thanks. First of all, I want to just take a step back. If you look at manufacturing, many times the perception is this old oil and hammer process, right? That's what's happening on the shop floor. That was many, many, many years ago, and it's dramatically changed the way things are now produced and made. And that originates from the product itself. The products that are being made and that are being delivered to end customers, they are highly complex. They are an integration of electronics, of software, of mechanical parts, all that have to work together. So to deliver those products as well that end customers are looking for, they have to be manufactured in a complex way as well, or that introduces a lot of complexity. And as part of that whole process, while companies are trying to deliver on the solution or on the product that the end customer is looking for, there are many compelling challenges that they face. The first one is what we call as consumer-driven customization. I think the whole idea of personalized products, the car of one or the device of one, which is personalized to your specific needs. That requires a big change in the way the product itself is designed so that you can incorporate the end customer's needs, and then the way the product is manufactured. So you have to make sure that you have the exact specifications for that individual product, and those are configured into the engineering and into the manufacturing process. That manufacturing process changes where you are trying to make one unit at a time. That introduces a lot of complexity. The assembly line process, which was there in the past, where you would roll out the same vehicle on and over again with a different color, if you will, is no longer the same. You have to configure each vehicle to each customer's specific needs, and they are individualized for that specific customer in terms of how that machine or how that car or whatever else will perform. So that adds a lot of complexity into the manufacturing process, and it really makes it very, very hard for these companies to ensure that they can deliver on the promise while still maintaining their operating costs and their operating margins. End of the day, they still have to be a profitable business. So that adds a very complex dimension into the way companies can perform. And that's why the need to adopt new technologies, new processes is probably the only way that they can serve this dilemma and this complexity that they are facing.
Great. So thanks for that, Rahul. So you're talking about, can you give me specific examples of technologies that are actually enabling this personalization and how this complexity is reduced?
There are two key aspects in terms of what technologies can be used. One is using technology to enhance the process, or using technologies to enhance the functioning on the shop floor. Things that can be used to make the products produce better. And then the second piece is improving the process. You cannot underestimate the need and the value of improving the overall process that will be used to manufacture the equipment or the product that you're looking for. Because that process is going to give you that flexibility to have that individualized product produced. Because unless you have a well-defined process that can take care of these different needs, you will not be able to produce that end product that you're looking for. So there are many key technologies that are helping in that whole process. Some of the key things are what we call as the digital twin of production. The digital twin of production allows you to evaluate your complete manufacturing process before you actually start making anything. There are capabilities around additive manufacturing, around AI, artificial intelligence, machine learning, AR, VR, which allows the operator to become more efficient to use the equipment on the shop floor, as opposed to learning every time and having only one view, taking advantage of things like augmented reality or virtual reality allows them to quickly learn new ways of doing things. So there are many new things that are coming in robotics that make a big impact in terms of how things get manufactured as well.
Today, we have Mr. John Nandry, who is the co-founder and chief manufacturing officer at Fast Radius. It's one of the startup companies in digital technology and manufacturing that's right in the intersection of digital technology and manufacturing. John, welcome to the course.
Thank you. Thank you.
And John is also a Michigan alum, engineering alum from Michigan. So welcome back to Michigan virtually.
Yes, it's good to be here. I wish I was there in person.
That's right. Yeah, we wish to. I'm sure we'll get opportunities for that. John, as you know, this course is about digital technologies and the future of manufacturing. And, we in this course have been talking about how some of the emerging technologies, right, and also the enablers such as cloud computing, right, is just democratizing the access to technology capabilities to big and small companies, and fundamentally transforming the way we understood manufacturing. And your company, Fast Radius, is just fascinating to me in terms of how you describe your business model as cloud-based services, manufacturing services, right? I mean, kind of you almost do so many of the manufacturing functions, and primarily through cloud. And I'd like to ask you from University of Michigan here, and then you went to the McKinsey strategic consulting experience, which is in fact really well still a sought after company by our graduates. So what kind of motivated you to take this shift and then jump and be a co-founder of this startup?
Mm-hmm. Yeah, absolutely. So my whole life, I've loved building things. I grew up outside Detroit. Cars are in my family for generations. The automotive industry, and I've seen how important making physical things is for the world, our country, our communities. And so that's went to Michigan, studied engineering. Went to McKinsey and focused most of my work there on industrials companies, typically in the manufacturing or operations functions. Was always very excited about how you bring new products to market, new things to market, or figuring out new ways or innovative ways of making things that kind of fundamentally enable, new experiences for the customer or outcomes for the business. And so, while I was at McKinsey, I worked on some of our initial work in Industry 4.0, as it was, starting to become called, and helped to create what we called the digital manufacturing practice, and help my clients think through the impact of technology on their operations, and how do you drive incremental value for the business and the customer, and then how do you then go deploy that out across your factory network. And this kind of Venn diagram overlap of technology and manufacturing just got me really excited. And it felt like there was an opportunity to create a manufacturing company from scratch, based in modern principles, on how to build almost like a tech company. But one that made parts, and one that one that worked in the physical world. And so that led me to a few of my co-founders for Fast Radius, and And we, started almost 4.5 years ago now, which is wild how time flies. But and the real nexus behind Fast Radius is how can we make manufacturing just drastically easier and lower the barrier of entry for people who want to make parts, whether that is an entrepreneur or a startup. We work with lots of startups, particularly in the the drone and robotics space, or whether it's an engineer at a large company. We work with Aptiv or Colgate or even Rawlings for baseball mitts. And they might want to make, it can be hard for them to work with their supplier partners as well. And it can be hard for them to figure out how to use new manufacturing methods and how to learn about what new manufacturing methods could drive value for their business. And then how do you then go and take that and apply it to make new parts or make new ultimately end products for customers. And so that's what drives us, and that's what kind of driven us to also, as we scaled up as a new manufacturing company, we ended up writing a lot of software to run our business, because how we wanted to operate our business, there wasn't software that we could use to do that. And so that's how we ended up writing a lot of our own software to run the business, but then also to interact with our customers. And so, our goal is, much like, we talk about much like how cloud compute revolutionized, the digital world and kind of digital product development. We believe that our model, which we call cloud manufacturing, which, is really founded upon the principles of giving our customers access. We talk about leveraging centuries of engineering knowledge, and giving them access to that. Elasticity around, capacity, in terms of kind of, specific processes, but also location, enabling much faster speed to market. So going, from prototype to production, within days and weeks instead of weeks and months. Global scale, so providing that kind of resiliency and redundancy, globally with our production footprint. And then ultimately, driving down cost and increasing reliability and uptime. So that's a bit of an overview of the journey of what gets me excited and what got us excited about starting Fast Radius and how we kind of ended up where we are today.
The hexatech technologies trends that we've been talking about have enormous implications for manufacturing firms, both from the demand side, that is the consumers, and on the supply side, which is basically the suppliers, and also the internal operations within the manufacturing firm. Let's start with the consumer side. The trend we talked about, ubiquitous connectivity, that means consumers are more connected now with high-speed network. That means they have more access to information. They have access to other consumers. They have access to social media, so many other platforms, which means they are more informed. And this informed consumers are actually evolving to recognize the personalized experience that they need, right? So in other words, the trend is more towards what I would call as personalized experience. In fact, this topic of how digital technologies, the hexatech technologies, as they come together, how they are fundamentally reshaping the structure of business models across industries. This we researched almost 12 years back, and I co-authored this book with late Professor C.K. Prahalad, where we said that these digital platforms are now going to fundamentally alter the structure of business models, moving away from manufacturers producing products at scale. Basically, scale manufacturing is going to transform into what we call as personalized experience, one customer at a time. Basically, it'll not be manufacturers selling the same product to all customers, but the manufacturers will be personalizing the experience for one customer at a time. So these trends, we argued, that is actually evolving the customer expectations. Let me give an example as we go through this point. Sitting in Michigan, of course, we cannot, forget our auto industry, right? Let's look at auto manufacturing. Traditionally, this industry, used to operate in the following way. The auto manufacturers will invest a lot of resources and capital into designing a new product, a new car, and then they will take that to the market and sell to the market. And they expect the consumers to buy those products. And of course, the cycle works in the following way, that the consumers are expected to keep that product. They keep the product for 3 to 5 years, and then they come back for buying the next product. And the manufacturer, in the meantime, invests more resources to design the next version of the next remake of that particular model. So that's how it was to work. The engagement was more product-centric. The engagement was more about selling products, and the engagement gap in terms of between the two engagements of selling the next product was about 3 to 5 years or 7 years, depending upon who the consumers. However, more recently, companies like Tesla and other automakers bringing together all these digital technologies that we talked about, and they now reimagine the process of, in fact, making cars and selling cars and also engaging with consumers. Now, they brought the concept, of course, drastically new technology of how the engines operate. Of course, in addition to that, digitization of the entire car, which means that digitization of the engagement with the consumers, there is a real-time connection with consumers. And now this is actually leading to what is called as what I refer to as the personalized N=1 experience. As consumers want, personalized experience based on who they are and what they like. So these technologies that are connected cars are enabling manufacturers to get connected with consumers in a new way, in a real-time basis, so that they can better address some of those personalization requirements. Consumers are beginning to expect real-time engagement because of these features. They expect in the case of Tesla, for example, the manufacturer and the consumer, as they are using the product, are constantly connected on a platform. And so a service for the car could be kind of delivered either in person, physically, or sometimes the service could also be delivered through software, totally digitally. Consumers are expecting proactive solutions. When they have a problem, they want the manufacturer to see the problem before it happens. They don't want the manufacturer to wait for the problem. In fact, the consumers want reminders of their service appointment, or if their brakes are going down, or there is a problem with the car. They want, they want messages to be sent to the consumer so that they are informed proactively. Consumers are beginning to expect new product features after they bought the car. And this was not something, the auto manufacturers were used to in a traditional manufacturing setup. After buying the car, consumers of, more sophisticated cars which are digitally connected now, like the Tesla or the Volvo or BMW, where consumers expect new features to come to the product through software update. And that is happening. In fact, companies like Tesla are giving new features, every month or two, in terms of the consumers are now, for the money they paid 2 years before, they're still beginning to continue new features through the product. And in summary, what I'm arguing here is that there is a new structure of business model that is evolving in terms of the consumer expectations, and also in terms of the manufacturers' readiness to meet those expectations of the consumers. The Hexatech trends related changes that are coming to the consumer side that we just discussed, I think those changes are bringing some enormous challenges to the internal manufacturing operations. Let's take, for example, the demand for personalized attention from consumers. We talked about the N=1 personalized experience demanded by every consumer, right? If you just bring that expectation into the manufacturing operation, it does not connect with how traditionally manufacturing operations were designed. Traditional legacy manufacturing operations were designed for manufacturing at scale. That means you manufacture, 1,000 or hundreds of products in a lot. But this is the new demand that is coming from consumers is not about lot size of 100 or 1,000, but it is moving toward lot size of 1, that they pay attention to one consumer at a time. Now, this change, whether it is the personalized attention to the consumers or the expectation of the consumers for real-time engagement with the consumer on on a need basis, expectation for rapid features that are being raised by the consumers. To meet all these demands, manufacturers, I believe, need to rethink their business processes. They need to rethink their technology architecture, and also they need to rethink about their talent composition. Let's start with the business process first. All the business processes in a manufacturing firm are encompassed in digital solutions. We know that. But the way they are encompassed in digital software now may not allow for the flexibility to meet the requirements of personalized experience demand coming from the market. So manufacturers need to look at how would they change, how would they kind of build this flexibility into the business processes to cater to the one customer at a time. Second, at the technology architecture. Often a common challenge within manufacturing firms is that the automation of separate units and machines and connected to digitized interfaces, that's often referred to as the operations technology. Whereas the digitization of business process that runs the business is often referred to as the information technology inside the organization. It's often the case that the operations technology and the information technology do not connect very well. And that gap creates a lot of challenges. So organizations need to rethink about platforms that bring these technologies together for seamless integration. Now, last, coming to the talent. Solutions through digital technologies, as expected by the consumers we talked about, I think they're going to need rapid experimentation of new ideas, and that's going to demand talent and skills where people have experience in multiple functional areas. You're looking for multidisciplinary skills in your talent. And also, of course, there is going to be demand for talent that understands digital technology, is more comfortable with solving problems through these technologies. So companies need to rethink that. And finally, it comes to culture and leadership as well. Because coming out with these new solutions and innovative solutions and reimagining process with digital technologies is not going to happen one go. This is going to demand a culture of experimentation where people can try new solutions and solve new problems. Hence, it is up to the culture and leadership to encourage this kind of experimentation, capacity for experimentation within the organization. In other words, what I'm arguing is that there is a set of new capabilities that manufacturers need to build, in order to cater to this new demand and build this new customer engagement and business models as required by the market. So, Bill, I would like to kind of post this a related, connected question from that. We just heard from Rahul in terms of how technology is, bringing these new capabilities to manufacturing and enabling them to, go towards personalized products. In your experience, you worked with many of, Siemens customers. How do you see that, the customers are coping with this, in terms of what kinds of challenges are present in introducing these kinds of technologies? And especially, could you comment this, starting from the incumbents in manufacturing who've been there for many years and who kind of perfected the traditional way of manufacturing? What kind of challenges are they facing?
So I think one of the biggest challenges that's hitting the space right now is complexity. And complexity is driving these trends and these curves that are advancing the industry. It's not just complexity on it's not just complexity on how to achieve the consumer-driven customization or lot sizes of one without a mass production environment. It's how to take these legacy operations that have worked with these OEMs for so long, and adopt quickly. Right, you're talking about taking legacy processes, legacy data, and changing and digitizing a process before, which might have been handled by paper or Excel sheets, even in some mandatory ways, but they worked at this point. The result there is the risk that they are introducing into their system is low collaboration and these silo teams, and many of the OEMs have relied on written instructions for communications. And each time that a copy or an interpretation of data is introduced, it takes painstaking efforts to make sure that the integrity is followed all the way through the process, from design all the way through manufacturing. And if you do not have the digital twin of production, you've not digitalized your process, you're not working towards automation and connecting all of these individual pieces from beginning to end of the manufacturing process, you're bringing risk into your environment. And that's the challenge and the trade-off that these OEMs have to make. You know, what's the level of risk that they're comfortable with versus the reality is that more competitors have lower entries into the space and have with this digitalization technology, and they're able to level the playing field a little easier than they were before because of this technology. And so it's balancing all that on how to bring it in, how to bring your suppliers and the supply chain into your digitalization process, and continue to have your stamp in the manufacturing space.
Great. Thanks, Bill. Just want to follow up on that. Certainly, they address this complexity with technology, but let me go towards the cultural side of it. I mean, how do you see the incumbent? What kind of challenges do they find in adopting these technologies? Especially, I can see in terms of sometimes this may actually automate a process and then reduce the number of people needed to work in this particular segment of manufacturing from by factor of 10 or something like that, right? I mean,
yeah. So that's the biggest challenge, right? You have an aging workforce. You have a perfect storm that's happening right now. You have an aging workforce. You have the need for automation, and it's affecting your human capital and your manufacturing teams. And so of course, there's potentially some resistance to that, but there's also opportunity in that. And the opportunity is to embrace this complexity and pivot towards this more automated environment. And then that pivot and that more automated environment opens up other opportunities downstream, including additional streams of revenue, possibly service contracts, things like that, as we bring in and talk about IoT and we talk about the back end of the manufacturing process and the service and lifecycle aspects of it.
Rahul, I'll actually follow up on this point that we made about the enormous opportunity that is being presented with these technologies, how they are fundamentally transforming manufacturing. However, we know that the success in any digital transformation is also dependent upon the talent that you have that understands how to kind of use these technologies, understand these technologies. So what would be your short message to our students, student community who are actually trying to learn these technologies or have some interest in manufacturing as a career?
The one simple word I would use to convey to the student is learn and adopt. You are at that inflection point within the industry. You are the ones who can actually train the rest of the companies as well, the traditional enterprises, and you're at that perfect spot in your careers to come in, learn some of these new technologies, and adopt these technologies for usage by these companies. Because even the companies do not know these new technologies. They are also trying to learn at the same time. Mm-hmm. So you are at that perfect inflection point to take advantage of these new capabilities and help the traditional companies move in their journey to this next generation of manufacturing processes. So it couldn't be better timed in terms of how this can all work together for you as an individual, as a student, because all these companies are also trying to learn this at the same time.
The new capabilities that the firms are acquiring through digital transformation using the technologies we just discussed, I believe that these digital capabilities also act as an insurance for these manufacturing firms against any of the global shocks that they may face. For example, they could be facing an environmental shock. They could be supply chain shocks or coming from the financial markets, and it could be from a global pandemic, right? But I believe that these digital capabilities, provide the insurance because let's, for example, take the environmental shock. Let's say, there is a big storm or there is a earthquake or a flood, which basically disrupts a significant part of the supply chain. Now, the new levels of transparency, visibility, and the flexibility that comes from these digital technologies allows these manufacturing firms to reconfigure the resources rapidly so that they can respond back fast to these shocks. Similarly, if there is a financial shock, the digitally mature organizations will have the capabilities where they have visibility to the financial risk that they are exposed to. And hopefully with those kind of visibility, and they'll be able to take action that enables them, equips them with the capacity for action so that they can, mitigate the risks coming from there. Similarly, we saw, more recently in the COVID pandemic, right? There's a global pandemic. What we found was that manufacturing organizations were more digitally mature in their digital transformation. They've had the capability, as we discussed earlier, to manage their operations from central locations, and get full visibility of their entire plant, end to end across all processes from a central locations. And given cloud computing, they could actually, now the manager, she could actually go back home and do the exact management of a team and the processes right sitting in a remote location. In other words, this digital maturity actually enable these firms to counter the kind of challenges coming from this pandemic in a much easier way than the challenge it was for, or the struggle it was for other organizations. Post-COVID, what we're seeing is that digital capabilities are also emerging as strategic differentiators. In a recent survey by McKinsey and Company, where they surveyed more than 1,000 organizations, and when they asked about the level of ambition of these organizations when they planned for digital technology investments, and they found that 7% of them said they want to become a tech company. This could be a manufacturer. They could be a manufacturing, maybe refrigerators and washing machines, any appliances or automobiles, but they have an ambition to be a tech company. In other words, that's the importance of tech capabilities now. 51% said, that they want to differentiate themselves in the competition. That means these digital capabilities are becoming differentiators in the marketplace for manufacturing firms to compete with their competitors. And of course, more interestingly, I saw that 28% of these respondents said that they are doing this investment just to keep up with the pace. That means, just to survive. In other words, all other companies are moving the direction faster. It is a race about who's going to get there, with all the best capabilities ahead. So in other words, it's not a choice. It's like, how fast do you start, and then, how do you kind of, progress in these capabilities. Similarly, the same survey in a different segment, they talk about the importance of tech leaders. In this part of the survey, what they did was they actually classified the 1,000 organizations, the respondents into according to their business performance, and they looked at the top 10 percentile of business performance, right? In terms of the top 10 percentile rated highest in their business success of their organizations. What they are finding is that 52% of those respondents, they agree with the statement that their tech leader plays an important role in shaping the business strategy. So the tech leader playing a role in the business strategy, that's very interesting. Similarly, when they asked about the agreement with the statement about the tech leader playing a central role in the company's innovation, right? Whether it's tech related or not, general company's innovation idea, they found again 50% of the respondents from this top, decile top 10% of business performers, they agreed with the statement that these kind of findings actually they show the significance of the role of tech talent and tech leadership. In other words, what we are seeing here is there is an emerging premium for talent that understand technology, talent that knows how to apply technology to solve business problems. Now, following from what Rahul and Bill just told us about the trends of these technologies of bringing to the manufacturing industry, they addressed the ability to deal with complexity and the ability to move towards personalization of products. Jim, I will now turn to you, because with your experience, especially in the pharmaceutical industry, and given the current context and the time we are in, we are right in the middle of the pandemic globally. And and we're all thankful to our scientists and the pharmaceutical industry of bringing out this vaccine, successful vaccine in a matter of 6 to 8 months time, where I still believe, in April 2020, we were all, we didn't know what's happening, and the general estimation for vaccines were at least 2 to 3 years based on the past experience. So can you comment on how technology has transformed both drug discovery and production of, the drugs in the pharmaceutical industry?
There's no doubt that the pandemic's had a big impact on the pharmaceutical industry and on life science products in general. I think what we've seen is that the pressure of time has led to use of technology throughout the life cycle, both in the discovery of drugs and in the push toward advancing the application of digital simulation technologies at the molecular level to better understand the physics and the nature, if you will, of the drugs and how they might perform for the vaccines that were developed, and then through into the clinical trials themselves and into production, where production digital twin technology has been used to simulate the flow of materials and the manufacturing processes in a way that has dramatically compressed the amount of time that has traditionally been taken to develop a drug. And so what we've really seen is that the pandemic has acted really as a great accelerator, specifically in the pharmaceutical industry, to take advantage of some of these technologies that have maybe actually even been around a while in other industries, but maybe not quite as successfully applied or not acutely needed as we've seen in the pandemic. So it's had a big impact. And the way that I often describe it is that it's broke the mold. So I don't think we're going to go back to older techniques where there was, let's say, the luxury of as much time and more manual, let's say, test-based techniques. So I think we're going to see this continued acceleration towards these digital technologies for discovery and then tech transfer through to manufacturing.
Today, we have two industry experts from Siemens. We have Bethany Herr, who is the member of the Global Strategy and Marketing Organization at Siemens. And we have Tavia Carson, who's a HR executive at Siemens. Both Bethany and Tavia, welcome to the show.
Thank you.
Thank you.
Very happy to be here.
Yes, thank you.
Bethany, maybe I'll start first with you. As both of you know, the context of we are doing this series of courses around digital technologies in manufacturing, how manufacturing is being transformed by some of these cutting edge technologies. And in my opinion, as I've been kind of designing this course, the transformation coming from these technologies, whether it is artificial intelligence, digital twins, Internet of Things, or additive manufacturing, I think the transformation coming from these are quite profound, and they have both business and social impact. And certainly we know that these technologies infuse enormous new capabilities into the organization, which allows manufacturers to manage more efficiently, effectively, and hence deliver more value for their customers and also, for their shareholders and probably employees as well. But at the same time, there's always a question in terms of the benefits coming out of this change, right? Is it being distributed? Is it being accessible to everyone? And as you know, as University of Michigan, we take diversity, equity, and inclusion as a very important priority for us in all the programs we do. And so this discussion I would like to have in terms of how do you see the DEI issue coming here, and with your background, I know both of you are serving as part of your DEI council within Siemens, or you're co-chairs of that, right? So I thought it would be great to have this conversation with you in terms of, given this transformation of the technology going on in manufacturing, what are the DEI issues you see here?
Well, it's a great point, and I agree with everything that you said here. I think adding the fact that there are business and social implications to digital transformation is perhaps side of the story that I haven't quite heard very often. So thanks for bringing it up and raising the issue. We speak to our customers. So from Siemens Software, we speak to our customers about digital transformation all the time, and in our conversations with our customers, it often comes back to the pace of change and how things are changing so rapidly today, perhaps faster than they ever have before. And so what is happening is data is piling up faster than ever, like piles and piles and mountains of data. We've got new technologies entering the conversation and the strategy faster than ever. And we have new, like you said, new capabilities, but that also requires new or different skills. And so with this pace of change and everything that is happening as sometimes we say the physical and the virtual worlds are beginning to blend, or those boundaries are beginning to blur, it's creating pressure. And it's creating pressure on the human beings of not just our organization, not just your organization, but every organization, and especially manufacturing. And so once we start really focusing on what the humans of manufacturing and of business are facing with, I believe instantly the concept or the points of diversity, equity, and inclusion must be on the table. There are many statistics out. McKinsey had a report recently that showed that organizations that have appropriate gender diversity have around 15% increase in profits over those organizations that don't. So it's a non-issue. If we have human beings under the pressure of having to figure out and keep up with the pace or take advantage of the pace of change that's happening with digital transformation, we, the management, the suppliers, the manufacturers, have to be doing things to help the humans. I keep saying human beings because we're not resources and we're not employees. We all have needs and to learn and grow. So that's where the DEI issues come from. And I'll pass it over to Tavia to really focus on the place to start during this transformation.
Thank you. So I agree with everything that's been said thus far, but the place to start that we found in our journey in diversity, equity, and inclusion, which for Siemens has been for the better part of 19 years, has been to assist in creating a pipeline of talent so that we as an industry, specifically a software industry, previously only wanted to make sure that we were creating next generation software engineers. That was our platform. That was our thought process. That's all we did. However, as this digitalization is coming faster, we're starting to understand that we need to know or position ourselves as a company to our customers, which are other companies, that they need to understand more than just software engineering. So we partner with an organization called AMI, which is the Advancing Minorities' Interest in Engineering, where we as industry are partnering with our customers like a Boeing or Lockheed or General Motors. We're in that room with the 13 ABET accredited HBCU engineering schools and government representation, so that those three pieces come together, or those three entities come together to talk about the trends that are happening outside of a university setting, so that we as industry can say, this is what we're seeing, this is what's happening in this industry, specifically in the industry of engineering, and talk to our customer directly. So GM, we're partners on this board. Are you seeing more? Are you getting what you need? Are you getting the students that you need? Because we as a software company are going to partner with these schools to make sure that they understand the software that's needed, that you're going to have to continue to produce as fast as you are. And oh, by the way, we're watching this trend change where students, you can no longer rely on just your engineering degree, but you're going to have to understand marketing, strategy, sales, market trends, etc. Because of the fast pace of this change, you can no longer rely on just your engineering degree to take you to that executive or that level of change, or as someone that's going to be making decisions. You need to understand the entire, what we have already known in our industry is, which this is called life cycle management, the cycle of a product. How does that work? The only way that a student can come into our company and truly elevate themselves and be mentored into a legal or a leadership role is that they not only understand the software and they understand engineering, but they understand strategy, they understand marketing, they understand how to position ourselves in that market so that we are that go-to company. And the only way we can do that is that we are bringing in diverse talent. So as a person part of the HR team, it's incumbent upon us to be intricate in that by leveraging our DEI processes to not only produce diverse talent, but to bring that diverse talent into our company and to mentor them into those leadership roles.
And can I add one to that, Krishnan?
Yes, please.
So Tavia really shine the spotlight on the issue of not having a diverse talent pipeline. But we also have an issue of our immediate future leaders who may not be the ones to kick off the digital transformation, but are going to be the ones to lead our organizations through the transformation. Just because maybe organizations have not been intentional about the mentoring, the coaching, the succession planning in the past, we still have, we still are struggling with having the next set of leaders have diversity of thought, of gender, of race, of orientation. And so it's not just bringing in the talent that organizations, and Siemens is right there with you. We also are focusing on, okay, how do we make sure that the next set of leaders who are going to lead us through and lead the new talent that comes in are not just prepared to lead a more diverse talent pool and employee pool, but are diverse themselves.
It's an excellent point. I mean, it's not just about, So first, Tavia, thank you for, informing us about the partnership that you have, where you create an ecosystem with your customers, with, external organization, with education institutions to create, to kind of create this talent that we are looking for, and then create opportunities for a diverse set of students. And I was, in fact, just going there in terms of, what do you do with the existing employees, right? I mean, thanks, Bethany, for today, because there are two problems to it, right? One is the incoming talent, and then, in your opinion, what is it? Can you give some examples of what are companies doing with the existing team that they have to kind of bring this awareness about DEI? I mean, everybody knows kind of DEI, kind of how to spell it or how to kind of what the higher level meaning is, but what does it really mean in the context of this digital transformation we are in? I mean, it is people who get it and people who get on this boat are going to be very successful,
Right.
and people who don't are, I think, going to be left behind. I mean, how do you kind of get this narrative or this kind of awareness that you build, either how you do it inside your organization or how are other companies doing it?
So I'll take the first part of the question. So how Siemens has decided, how we are doing that is what Beck touched on before. So Siemens has a 3-pillar approach to DEI. So we have what's called workforce, workplace, marketplace. So that workforce, so the first part that I talked about earlier was workforce. That's our alignment with the talent acquisition team. That's how we're bringing in that new talent. So we are positioning ourselves with various organizations, things like OSTEM, which is targeted for the LGBTQ community, and really partnering with those organizations to start to bring in that pipeline of talent. But then, as you pointed out, what happens once they're in the workforce? How do we start to mentor and cultivate those employees? That's where workplace comes into focus. So we take that pillar, which is workplace, and start to create mentoring programs. We start to have what we have now launched, which is called Growth Talks, where we are not only encouraging our employees to take ownership of their careers, but to have conversations from really day one when they walk into the door with their manager to say, I want to be able to move my career. So we do put some responsibilities on the employee. It's not just we hand you a map, but we do encourage new talent to come in and say, if you want to move your career, here are some very easy transitional type courses that we suggest. We have an entire set web page on our HR site that employees can start to look at. Let's say I want to be a marketing manager, right? I want to be in management in the marketing space, but I come in as an engineer. Okay, I've come to this company as basically an engineer with some marketing experience. However, as Siemens, we're going to give you a very succinct educational pipeline to be able to start to educate yourself, because we are now looking at employees to be more self-sufficient, to be more aggressive in their careers. So I'm going to take the opportunity to look at the courses that we've already laid out, we've already found for you, take those courses, and then to start to build out your career, right? You're starting to make your career be what you ultimately want it to be. And it's a 2-part approach. So yeah, my employee is going to do the classes. Then I'm going to look at my managers. Managers, are you monitoring your employee through this process? How are you talking? How are you having these growth talks? Because we've implemented that, where we're having these conversations. How are you growing? What assistance do you need? What outside sources have you tapped into to continue to keep your mind on the trends that are moving? So it's that workplace part of our 3-part program is really where we start to cultivate that. And then there's mentoring programs that we started. Beth knows one in particular, where we are now looking at our women population. Again, women are a big part of this male-dominated field that we are in, and starting to mentor them, partner them with female executives so that they understand the nuances and get a behind-the-scenes look at what it looks like to be in an executive role as a woman in a male-dominated field. The ultimate goal is that we will have enough diversity at that executive level that everyone comes into the company will know that there's opportunities across the board, and they will automatically gather the information they need to start to move their careers forward. But we're at the beginning stages right now. We're starting to have those growth talk conversations. We're starting to build that trust between employee and manager so that those pipelines can continue. Because the recruiting piece it's a challenge, but it's an easier part. It's cultivating the culture inside. And that's also part of that workplace, because while we're cultivating employees, we're also having discussions about ethnicity, diversity. What does that mean? We're talking about how our differences are not what defines us as Siemens, but it grows us as Siemens employees, right? So we're not just mentoring, but we're having open, courageous conversations about what it means to be diverse in a organization like a Siemens or like a Lockheed, like a Boeing. What does that mean? How are your talents being brought out so that the workplace becomes an avenue for that growth? Right. So it's a breeding ground for growth because everyone is doing the same thing and having these very open discussions. Some of them are difficult. Some of them are not easy. In this atmosphere that we live in, some conversations are going to be very difficult for us to have. But we realize the importance of those, that if we don't have them, if we shy away from them, we're not going to be in line with the trend of what's happening outside of the walls of our company. And we encourage that of all of our customers as well.
Great. Thank you.
Mm-hmm.
You want to add?
Is there a moment to add 2 thoughts to that?
Sure, absolutely.
Okay.
Yes.
In addition to the work that we are doing with our employees and with our future talent, we're also seeing a trend where organizations are setting diversity targets, and not only are they setting the targets for the percentage of females hired, the percentage of female leaders, the percentage of Black Americans or Asian Americans. This is speaking from an American perspective. Companies are also opening up the transparency of those targets, and I believe what we also are seeing is that organizations and customers and suppliers are beginning to ask for it. It won't be long before those targets and where you are in your progress of hitting or exceeding the targets can no longer be inside or proprietary information. And so I believe that that's another shift that organizations, Siemens as well, is going to have to face very soon, if not it already being here.
Our learning objectives in this course are as follows. We will focus on the primary question of what is this technology? What is IIoT and how does it work? We will also discuss understanding the business use cases of this technology in a manufacturing context. And we will talk about the component pieces of technology that actually contribute to these IIoT applications. And then we will also focus on what does it take to successfully implement these technologies. Now, what goes right, what goes wrong, what all things they need to take care in order to make sure that they're successful. We will also spend time understanding the various dimensions of business value benefits from the industrial Internet of Things technologies in manufacturing. We will focus on specifically the challenges, like when companies want to roll out applications of using this technology, then they are likely to face some challenges. They need to be aware of that. So we'll focus on those. And we will also address some of the risks that come with this technology that companies and users of this technology should be aware of. And finally, we will spend some time understanding the future trends in this technology. Like in the next 3 to 5 years, what is it that we can expect and how would that shape the future of manufacturing? Our mode of delivery and learning here is going to be combined. It's going to be including some video lectures as we are doing right now. We will also have reading assignments, reflection exercises, and learning assessments. In addition, we have also got some industry experts who've been generous with their time to join in conversation with us, sharing their decades of experience working on this technology, making these applications successful in large manufacturing organizations. So here are some of these experts who would be joining us in this course. First, Dr. Annie Zhang, who is the Digital Innovation Specialist in Advanced Manufacturing at Ford Motor Company. We have Mr. Jayanta Banerjee, who is the Group CIO at Tata Steel Group. That's one of the largest steel companies in the world. We have Kathleen Diwak. She's the Chief Architect and Head of Global Architecture for MindSphere at Siemens. MindSphere is one of the industrial Internet of Things platform from Siemens. We also have Nash Chakraborty from Siemens. He's the Senior Director and Global Marketing. We also have our own Professor Yogesh Gyanchandani from the University of Michigan, who heads a Center for wireless integrated microsensing basically is, it is a sensor center that focuses on microsensor technology. And he's also a professor in the computer science and electrical engineering department here at the University of Michigan. And we have also a startup company, which is primarily built around the sensor technologies and IoT applications. And we have CEO Sasan Timuri, who's the CEO of Omniscient, and the basic idea research for that technology happened within the University of Michigan. So we'll get some of the startup perspectives in addition to perspective from all these business leaders. In order for us to understand the industrial Internet of Things, or IIoT, it is important for us to first know what is IoT, or Internet of Things. In fact, we should start from relating from Internet to Internet of Things. If you recall, the history of Internet, as you see in the left-hand side of this chart, it started with the concept of a network of computers, a network of traditional computers as we understand, several decades ago. In fact, primarily it started with applications in defense and research applications in universities, and that's where those drove the need for a network of connected computers, and that we used to call this as Internet. Of course, those industrial machines used for research and development or defense applications then moved to kind of the personal computers you and I, all of us use, and they started connected to the same network called Internet. Over time, with the advances in microprocessor technologies, communication, in fact, what has happened is we have more and more devices that are intelligent, that have got microprocessors in them. And so these devices, they also began to start connected to the same network. And that's why from Internet, it became Internet of Things, because it's not just the Internet or the network of computers, but now you can connect your phone, your car, you name it, your washing machine, anything that you have that has got a microprocessor, has got some intelligence and a capability to sense, that can be connected to the Internet for a particular contextual application. So that became the network of not just computers, various other devices, often called a general term called things. That's what evolved into what we call as the Internet of Things. In order to understand these applications on Internet of Things, let's kind of start with a simple example that all of us can relate to: a thermostat. We all recall the analog thermostat, like a thermometer we used to have, which actually would track the mercury will show the level of temperature. But then you switch that to a digital thermostat, right? A digital thermostat, what it can do, that it again has a sensor to sense the temperature, and of course it can show the temperature that is there in your house and display that. That's one application. It can sense the temperature and display that. However, let's say if we can if this thermostat is more intelligent, it's got some microprocessor, and it can do something additionally. For example, it can connect to the cloud. Okay, it can connect to the network. Suppose instead of this thermostat being just connected to your home, it is now connected back to the network as well. So what does this lead to? Well, if it is connected to the network, then the thermostat can actually now send data, store data in that central location in the network, and also access data from there. Now, that has got enormous implications for various ways we can put this into use. In fact, primarily for consumers' convenience or for business value in the context of companies. How does that happen? Well, once you put this information in the network and make it accessible by the thermostat, what you could do is that the same information could be accessible by any other thing or device that is connected to the network. For example, your phone. So from your phone, you can now connect to the same network, access the same data. So that means sitting here in my office, I can actually look at what is the temperature that my thermostat is showing at home. It's not just about reading the information that is given. Now I can also send a command back to kind of set the new temperature level so that I can either get my home warmed up or cooled down depending upon the time of the year before I get home from work. So this is a classic example of a simple example that we all live now, where we are connecting back to something that is sensing temperature, and then it is connected to the network, and we're using the network to get access information or also give instructions to what to be done in a remote location. This is a good example of what we call as Internet of Things and bringing some value for customer convenience. So how do we move from Internet of Things to industrial Internet of Things? Well, the same concept of thermostat, if you kind of extend this to application of interconnected sensors and devices and machines in manufacturing, including complex machines, assets, vehicles, robots, then if you can connect all these things and create contextual applications to improve the manufacturing process, just like the convenience we brought with thermostat, that application would be called the industrial Internet of Things because the application is in the context of manufacturing industry. The economics of the IIoT technology now is in such a stage that we can actually easily justify the business value investments. Because if you look at primarily the trends in terms of the cost of microprocessors, in terms of the power of the microprocessors and the cost of microprocessors, the power has gone up and the cost has come down significantly. Storage cost has come down significantly. These are some of the big trends that are actually making the applications of Internet of Things viable economically, in the sense that as a business, you can easily make a business case because the investment is not that high as compared to the returns you get back. In fact, a recent survey from McKinsey & Company shows that predicts that the industrial Internet of Things market would be more than $500 billion in just 3 to 4 years from now. In fact, they predict that we already have more than 8.4 billion devices that are actually connected to the internet, right? And this is supposed to also further explode. And with the advances in high-speed connectivity, like the 5G spectrum, for high-speed connectivity in communication networks, and again, reduction in storage technology costs or the microprocessors economics, I think this is going to be a big market as predicted by McKinsey & Company in the survey. As we discussed the Internet of Things in the industrial context as IIoT, we talked about how we connect various kinds of devices to embed intelligence in the manufacturing products and processes. In fact, these devices play an important role in collecting information in these manufacturing processes and enabling actionable insights through this real-time information. Now, these insights that we get from these real-time information, right, they come from a technology that is embedded in these devices. It's called the sensor technology. The sensor technology actually enables these devices to collect the information from the manufacturing process or the environment, whatever we are interested. And these technologies play a very important role in enabling industrial Internet of Things as a concept. You may also recall that and in the introduction of this series, I talked about the important hexatech trend, the 6 big tech trends, and the emergence of smart sensor network was one of the technologies that I referred to. Hence, it is important for us to understand the sensor technology a little bit more as we build our understanding around the industrial Internet of Things. So let us understand what is a sensor. We can take a black box view of sensor. It's something that takes an input and then can create one or more output. For example, we talked about thermostat. Thermostat takes the input is basically the current temperature in the room. It senses that information, and then it could either display that as one output, or it could send that information back to the cloud. So those are a couple of outputs. Now, your smoke detector in your room, another sensor that we always are used to, right? I mean, that's constantly sensing for smoke or something related to that. And then if there is detection, then it just beeps, okay? So that's another example of a sensor, with just a black box taking some input and then giving one or more outputs. More complex sensors, can also take multiple inputs. For example, you could have the same sensor that actually both senses your temperature, and it maybe senses the moisture in the room. And it could also, sometimes in industrial applications, you could have sensors that do multiple sensing, whether it is heat or whether it is movement, whether it is pressure, all this stuff. So when you take multiple inputs and then you can convert that into multiple outputs, of course, the sensors becomes a little bit more complex. That black box inside the sensor, now instead of being just a simple logic, the logic in that could be a little bit more complex, right? And then that's what is captured in the microprocessor chip, that actually where you program the logic of how that sensor should behave. We come across sensors in everyday life. In fact, you can kind of understand sensors in the concept of a simple, what I would call as the consumer sensors, that we kind of, come across these sensors on a day-to-day life. When last time you went to the grocery store, you would find that you're just kind of you're scanning your item that you're buying. There is a sensor there which is actually looking at the barcode often, and then reading that information. It could be multiple sensors as you're walking through the aisle in the grocery store. In some grocery stores, they also have smart cards which actually kind of digitally displays the information. If you actually scan a particular product, you want to know the price or some information about that particular product you want to buy. In some companies, it's kind of quite prevalent now where they use sensors or identification devices in their personal identification cards, and they can use that for gate pass to kind of open doors, where it senses and recognizes the identification of this particular card and then kind of give the required access that is needed. Those are some of the examples I call consumer sensors, because directly we use it as consumers, as citizens. And there are also industrial sensors in the context of manufacturing, like on the left-hand side of this slide. We could have, simple robots. The simple robots which actually kind of take some input. They sense the movement of some other part. They sometimes sense the movement of conveyor belt, and they take an action. Okay, there are multiple sensors inside the robots, and the more complex the robots, you'll see computer vision, and they call the eyes of the robot. They are sensors in some sense. And we also have complex, the PLC machines we talked a little bit earlier in the introduction. These PLC, the programmable logical controllers, they are actually, in other words, they're also big sensors, right? I mean, complex sensors, because it's complex logic, and you can pre-program them for how the machine should operate in a manufacturing context. So in other words, there are so many different types of sensors. I mean, here is a chart that actually lists some examples of sensors. You can have temperature sensor. We talked about pressure. It could be position sensors. There could be sensors based on the lat long. Where exactly the asset is positioned. You can actually track that, and you can sense for a chemical. You can sense for gas. There are so many applications. In fact, it'll be an interesting way to look at the application of what each of these sensors does, and then look at how we can put this together to create useful applications in a manufacturing or industrial context. Let's take one simple example of one of these sensors. It's often called as the RFID. You might have heard this term RFID. It's just kind of the full form is the radio frequency identification tag. And these are simple, microprocessors with an antenna, kind of transponders. They can receive and send information in radio frequency. So they are used as just storing information, sometimes just kind of for identification purposes. And there are simple RFIDs, and kind of they also, just like I talked about how sensors can be very simple sensors to complex, the same applies to RFID. And you would have seen RFID being used in manufacturing context to track inventory. It's used in grocery stores. Sometimes you'd see people take inventory, walking through the aisle. They will have a kind of a reader in their hand. They're trying to scan to see how many milk bottles are left on this aisle or something like that. They just capture that information to track real-time inventory information. Now, the RFID, the way it works is there is a tag, and there is a static tag that has got this information. There is a reader that actually kind of senses this tag and then reads that information, communicates with that with the tag, and then collects this information. Just we talked about how devices in the IIoT applications collect information and provide real-time information and provide that access to decision makers, so that they can now derive some actionable insights and make decisions to improve the manufacturing process. So in the case of grocery store, you would see that as they are scanning these RFID tags walking through the aisles, I mean, people in the back end, they are kind of getting this real-time information. They know exactly which particular product is moving fast or not moving, so that they start getting this real-time a transparency in the supply chain movement of this inventory so that they can replenish it faster. So that's one example of how RFID is used in terms of tracking the location, getting information, and of course also use some analytics to make some decisions. Today, we have Annie Zhang, who is the technical specialist in digital twins and artificial intelligence at the Ford Motor Company. Annie, welcome to the course.
My pleasure. Thank you.
Thank you very much for taking time from your busy schedule. I would like to open our discussion with a broad understanding from you in terms of how do we explain the concept of industrial Internet of Things, which is called IIoT.
I think maybe the one way to start it would be start with IoT first, Internet of Things, because that's just something that I think every one of us may be already living in it, but without really calling it out. I think we all have thermostat at home. And if you want to know your temperature in your living room, in the old days, you would use a thermometer and it might read, 70. That is how we got to it. Mm-hmm. But how can we get to the temperature easier or more regularly? I mean, if you want to know the temperature, today we don't know because we want the temperature to be set at a certain time. So therefore, you start looking at a device that's smarter than just a thermometer, but it also has a sensor that can measure the temperature, which is a thermometer. And by making it smart, what you do is literally you connect the reading from that thermometer to something that's smarter, could be an algorithm, could be something else, that can be leveraged to control the temperature of your room. And therefore, you have this device connected. And when we have the capability to connect this information to our internet, now you get that little thing called Internet of Thing. Not things yet, but that's the thing. But when you have a number of those, and now that's the term IoT come into birth. And we all know nowadays, we don't have to sit in our room to know what our temperature is. We can be in Cancun to adjust the temperature at home if so desired. And I'm sure you don't want to do that. So if we spin this concept into manufacturing, it's really about the same. We have so many plants globally, and each plant runs its own thing. We might not use thermometers, but if we ever use a thermometer or any sensors that's like that nature, guess what? We will be able to connect them through smart devices to the internet and eventually be accessible from anywhere. So I think that probably is the easiest way to get to understand what that IIoT is. It is industrial use of the Internet of Things, but it's more target toward manufacturing industry or any other industry type of usage.
Any building on that, can you so basically the concept of a sensor that you explained using the thermostat, right? Now, how would you categorize these sensors in terms of classifying them, the different dimensions of the complexity of the logic inside, and how do they vary by cost? How do you categorize these sensors?
That's a great question. I mean, if we were talking about these IoT at a force setting, we probably don't get into how do we classify them as much, but we do use them for a purpose. And I think it depends on their functions. We would call them differently. For instance, error proofing is one of the most popular thing I think that's used in any plants that use automation. Error proofing use a number of different sensors, and I don't know whether we call them error proofing sensors, but there's a category of such, which is error proofing. Okay. And then there's also things like getting to know the actual machine or the asset states And most of those will be, it's through the PLC, a programmable logic controller. Those is also very, very popular inside any modern plants. So I think between sensor and PLC, I think that probably is how we will try to classify them. But as far as IoT goes, we actually expand the concept of that to any device. That's the thing part. Any device that we use that can generate data. We consider all of those part of IoT family, and we harvest on the information on that.
I understand the PLC part where there's a logic that is programmed. The first one, error proofing, right? We talked about. How do you kind of, describe how does that sensor work?
Okay, let me give you a specific example on the error proofing. Let's take a seat in a vehicle. There are seats, right? There could be leather seats, there could be fabric seats, or different color of seats. But when we put a vehicle together, there's only one seat that should go in there, right? If it's 10 color, it should be 10 color. You cannot put in a gray color seat. And error proofing really means that we do not allow operators to put in the wrong thing by design. So there's no way they can put a wrong thing in. That's error proofing. So what we do is normally when a seat, maybe a number of seats is lined up next to the operator will need to scan something to recognize what that seat is. And behind the scene, there will be servers and systems that will track, is this the right number for the right seat? If it's yes, of course, it continues. And if it's not, you definitely will see a buzz or Z or some sort, and it'll be apparent enough for the operator to know, oops, yeah, that's the wrong one. So that is in a nutshell, what an error proofing is.
Now, if you understand the trade-off between cost and complexity of sensors, it's kind of very interesting. I mean, of course, as we would expect, the simple sensors are going to be cheaper, and the more complex the sensors are, as we discussed earlier, they can handle potentially multiple inputs, and they can actually give multiple outputs. And of course, more importantly, the complexity of the logic in the middle, right, that we talked about, that's what's going to be increasing the cost. You'd see that as the complexity goes up, you would find, as in the curve, the cost of the sensors also goes up. More interestingly, we have to understand that it is the complex sensors that actually also create opportunity for manufacturing companies to, develop some contextual applications that will be very useful for decision makers to improve the manufacturing process, right? So, for example, in the context of RFID tag as a sensor technology, like there could be simple, what I call as passive RFID, where it just kind of, if I'm kind of carrying a RFID badge with me, then all it is doing is it is kind of recognizing me as with that RFID tag, and the sensor reads, then it knows that this is this particular employee with this employee ID or number, right? And those sensors, the passive RFID sensors, are very cheap. I mean, in fact, the cost economics of sensor technology, as we talked about, these, passive RFID, just storing that location, so storing that information, they actually just cost only a few cents now. However, there could also be complex RFID sensors, like, technology can be implemented with what I call with active RFID, where the RFID tag itself will have a chip and then will have some logic in it. So what it will do is it will actually take some actions, take some output actions, depending upon some information that is getting from sensors. For example, right, you could actually put RFID tags in kind of fresh produce that you're actually shipping, say from California. You're actually shipping tomatoes from California into Michigan. Let's assume that, okay? As they are traveling by road in trucks, I mean, the trucks are supposed to be refrigerated, and of course you certainly want the refrigerator to be on for those tomatoes to be fresh, right? But say, for example, for some reason, the temperature inside the refrigerated truck actually goes up because it's not working or whatever reason, or the truck is actually stopped in some location for a longer time. Then the RFID tag in those within the truck, kind of, in fact, attached to each of the pellets of the tomatoes there, they can sense the movement of the product. They can sense the temperature, and in fact, if it actually crosses a particular limit, they can actually send back information. And those are what I call as active sensors that has some logic in it to kind of raise the flag of something is wrong. So you can see. Of course, they are complex sensors. They're going to be kind of a little bit more expensive than your passive sensors. But at the same time, they are now giving more contextual information for manufacturers to take action. So we can kind of, if you're the retailer kind of selling those tomatoes, you get notification that, oh, the tomato is going to be either late or, well, the temperature is not good and they may be not good quality. You probably have to do some more careful quality inspection with this product coming in. Information like that, which often leads to improvement in the process or in reduction in cost, and so many dimensions of benefits you can get from those contextual applications. In fact, if you take the same sensor example, sensor technology, and there are so many examples that you can actually relate it back in the manufacturing context. It could be used in smart maintenance. So within the manufacturing process, just assume that if you have sensors and machines, and a particular machine, say, for example, it's losing its calibration or not working to the precision it is expected to, right? And there are some parameters you put sensors about those. Any deviation in those parameters, the sensor can actually capture and immediately send information back. So what does it do? Even before a machine is breaking down, if there is any deviation, if there's any quality issues, the sensor immediately catches that and sends it to the information back to the decision makers. And hence, they can actually kind of what I call as smart maintenance, because you don't wait for the machines to break down, but you actually proactively get information through the sensors to improve the decision making. Now, you can also make the supply chain more predictive, because just imagine if you're using RFID or similar kind of some similar sensor technology, say with your downstream supplier, then you could actually know as soon as the product gets shipped from the supplier through the sensor technology, you can say, well, this product has been shipped, is actually on the way. I'm actually going to get it tomorrow by 8 a.m., so that will be right on time for my shift. And if it's not going to happen, you will know that it's going to disrupt your shift. So this predictive supply chain, you can actually predict what's going to happen. That actually helps in improving the overall process operation. Now, you could also improve the customer service. Just like the example I gave you about a machine inside a manufacturing process, you could also do, in case you think about intelligent products. Now we'll see more and more products that are now software enabled. We have sensors embedded in them. And in fact, we will talk about this more in our next course on digital twins. But the point I want to make here is that if you have sensors in the product that's being used by the customers, you can use the same logic. And in other words, you get information through the sensors on how the customer is using the product. Not only that, you can proactively address any problems that the customer may face. So these are some of the examples that in terms of what you could use with the customer in the context of manufacturing. Sensor technology could also be used in safety. For example, there is there are regions in manufacturing you want to protect, right? I mean, you could actually kind of put sensors around them to make sure that people don't get into that area. Or you can actually sense for chemicals leaking, or you can sense for some gas leaking. So many applications of sensors that actually can improve the overall safety in a manufacturing context. In summary, what we talked about, we actually addressed, in fact, of what is the sensor technology, why the sensor technology is one of the fundamental building blocks of IIoT applications. Then we understood sensors from simple sensors to complex sensors. We talked about RFID as an example of a sensor, how it works, how it can be applied in manufacturing. And we talked about the economics of sensors, right, in terms of what happens to the cost of sensors as the complexity goes up. And then at the same time, it is the business value benefit that also comes with the complex sensors, and hence it is a trade-off decision makers we need to make how they design the application, kind of looking at the cost and also the business value benefit they get. We also then finally talked about how some of these technologies, sensor technologies, can be used in the context of a manufacturing operation. Jayanta, this discussion has been quite fascinating in terms of the journey of digitization at Tata Steel. Let me come to a specific technology like, Internet of Things, or IIoT as it is called. So can you give us an example of, IoT application within Tata Steel? And also it's being talked about that, often these digital technologies have also helped companies manage the global pandemic in a more efficient and effective way as compared to the competitors.
No, absolutely. This is the most passionate subject, and this platform, I personally take a lot of pride in working on it. So I will talk about it, and there are many other examples also I will give. So just going back a little bit, pre-pandemic, the question was very simple. So our CEO and MD asked a question that right now, how many people are in Tata Steel premises? How many contract workers? How many workers? And who are there? In which operation? Which part of the plant? What are they doing? And are they all safe? Because steel is a hazardous workplace, right? So it's not safe. So
you employ thousands of people, right, in Tata Steel?
Almost 70,000. So there's 70. Most of them are contract workers, but there are also officers and non-officers. So yeah, there is a demography. But total human who will be there in Tata Steel India is 70,000, and there are more in the other divisions of Tata Steel in India.
So the request from the CEO or the MD is visibility of who's where, is it?
Who's where and what is the count? A simple question. How many people are now? Not all 70,000 are inside the plant at a given point in time, because if they come and shift and whatever, right? So it's a simple question. Just give me and you all have the RFID badges. So people will say that, okay, now I have to go and check how many people checked in, and from the attendance register. Then you go and add. And by the time you do that calculation, the shift has completed and people will go away. And new people will come in, new shift will start. So it is impossible. You cannot do it. So what we did is that the following. So IoT, you asked the question of IoT. So we thought about, why don't we geofence the entire company?
Yeah.
Disneyland, if you look at, it is also following a similar method, right? To track the kids and for safety and all that. So we geofence the entire company and put around 40,000 beacons. The beacons are the receiving device. They're just there in different demographic inside the plant. And we used LoRaWAN technology, which is because of the lower frequency, its penetrability through metal barrier is very high. And steel is an industry where we need to focus on that. High frequency energy will not work because it will not penetrate through the barriers. So we use the LoRaWAN technology. So we had the technology part done. Then all of us carry some RFID card as our identification card, whether you are an officer, whether you are a non-officer, whether you are a contract worker. So you have an RFID card that you do your attendance and you come in, that's your identification card. So we just pasted another card behind it, which we called Suraksha card. Suraksha in Hindi, we can say it's a safety card, right? So we named it program as a safety program. And then whenever you are coming in and you are coming in close proximity, 10 meters with a beacon, the beacon is now sending data to the cloud every 2 seconds, about the coordinate of a person. So from that and putting the geospatial map on top of it, and we did a zone mapping of the entire organization. We created the organization, we did a zone mapping. We exactly know who is where in which location, right? That is the first and foremost. So in real time, I know that, okay, so many people, you want 2 seconds. It's on the real-time dashboard. Right now, these many people are here. These many people are at this gate. These many people are in this plant. All that is available. Just live dashboard. Now the second question comes. Now, so once you're done, you ask the question.
Yeah, Jayanta, just for the clarification for our student learners. So the geofencing is basically you take a geographical area and then fence it with sensors, small sensors called beacons, right, which actually kind of can track this particular card that you've given to them, with it just being kind of within that area or not. Correct?
Yeah. Okay. So you put the beacon. Beacons are devices which will just is a passive signal it will get.
It's a receiver,
and it's a 10-meter radius. 10-meter radius is the proximity that it covers, and you put it in whatever way you want to put it. It's not only on the border; you can put it anywhere.
Yeah, and it detects these card holders when they come near that particular beacon. Yeah.
10-meter radius it will detect, and then it goes into the cloud, right?
All right. Thanks for the
Yeah. And then there's a zone mapping. So I exactly know from the lat long that, okay, this is the zone, this is the exact area where the person is. But there is some accuracy issue of plus minus 1-2 meters, which is okay. Now the real interesting part. You asked me about the question of how did you excite the organization? Now this was done by IT.
Yeah.
Then we took it to business. We showed to MD and showed to all the executives of the company in one room that this has been done. Now they said, oh, I can do now. Now I can do the safety index. I can actually find out whether he has gone into hazardous location, whether he has gone into an unproductive area. So many new questions came up. So then the power of analytics come because the data is now there. The data has come to the cloud. So now we rode on the power of analytics and AI to analyze the data to say that you have a permit to do a hazardous job and you are in the hazardous area, so you are fine. But you don't have the permit, but I'm finding you in a dangerous and hazardous work area. So immediately you have to be retrieved from there.
Yeah.
Or somebody has fallen. There is an SOS button also we gave on the card. Somebody has just fallen sick and needs help. He or she can press the SOS button and immediately an emergency response team can go and retrieve the person. Look at the safety index of the company, right? Mm-hmm. And then there is another application of productivity.
Yeah.
So if you are just sitting idle in an unproductive zone, suppose there is a restroom and you are sitting in the restroom for 2 hours, let us say, either you are sick or you are just being unproductive. And the data will tell that you are not even moving. There is an immobility index. It will even beep. It will alert that, okay, the person is not moving for so many hours, right? Or the person is not moving from the zone where he's not supposed to be because that's the restroom, right? You're not supposed to be there for 2 hours. So it will also beep, right? Mm-hmm. So all those new use cases keep on coming. Yeah. Then what happened? Security. If I'm finding a group of people where they're not supposed to be, the security officer will get an alert that, okay, go and find out that why are these guys there? Because they're not supposed to be there. That's not their work area. Yeah. So they are come out of their assigned work area and being loitering somewhere, right? Yeah. So it has a security use case coming out.
Yeah.
Then COVID happened.
So before we go to COVID, so basically what you're saying, Jayanta, is that you put the basic IoT sensor infrastructure in place, then it's almost like imagination is the limit. You started getting productivity applications out of that. You started getting a safety application out of that. You started getting a security application, right? These are all like, how do you kind of manipulate and how do you use the logic of the sensors to derive actionable insights? Okay, thank you.
Absolutely. Actionable insights because you have the data. So once you have the single version of truth, now you just keep on mining the data and create different use cases. Yeah. Then COVID happened. And the most important dimension, the fourth dimension, we could find that business say now, very simple application, social crowd. We have to not allow crowd, right? That is the first thing. And in the plant, there are so many people and the workers are all flocking together in a 100 square meter radius. And there are so many people. Immediately from the same application, we could find out that so many people are close to each other. So there is a crowding that is happening. So social distancing norms are being broken. So we intervened and alert went to the respective supervisor or the plant chief or whoever. And immediately there was a public announcement system where people said that, okay, do not crowd here. Or a manual intervention was done to disperse the crowd. Mm-hmm. That is one application. Then we thought that why can't we measure the distance between two people? There is a beacon, there is a tracker. So we can do some mathematics and analytics and AI. That is where AI came in. We could optically measure the distance between two people. And if it is not 2 meters or 6 feet, we'll again raise an alert on the MIS dashboard that people are not following social distancing norms. And India, it is extremely important, right? Yes, because of the density of population. And we could manage the social distancing by doing digital response across Tata Steel, sitting in one command control room. Because everything, it is just alerting, right? Then we said that we democratize the data. Why didn't a command control room? Give it on the iPhone and Android phone on every officer. So their respective area, they used to get an alert. Okay, here you have to go and intervene because there is a social distancing norm that has been broken.
Violation. Basically, you made it as compliance. You made it as a compliance tool for,
Made it a compliance. Yeah. Then canteen. canteen, when you're eating, you're not maintaining social distance. The same algorithm started working there, right? Then we started recognizing facial masks. That is an imaging algorithm. So you're not wearing a mask, so the system will alert, right? So all these things came up. And then what we did, to your question that we started this discussion with, like in Argo Setu is an India government app. So we created a questionnaire for people. Have you been in contact with a COVID patient? Have you been in a crowded place? Are you feeling having fever or some other symptoms and all that? And that questionnaire will give you a status of either green or amber or red, right? Now, then also we are trying to now then see that is a questionnaire. But once you have come inside the plant, suppose you and me have violated a social distance of 2 meters, and we have been working closely together for say a couple of hours, and now I fall sick. I report sick. I have a COVID this thing. Then immediately the system knows now he has become a COVID patient, but yesterday or week before he was working with Krish, and they were together for a couple of hours or more. So Krish becomes now a highly susceptible candidate. So he has to be quarantined and medical intervention, or he has to be under observation. That is how the footfall management happened. The whole proximity analysis, real-time proximity analysis, that is a new use case that came up.
So basically,
right?
You converted them to contact tracing application.
Contact tracing. So became a real-time contact tracing, and at the gate, on your mobile phone, the security guard, you don't need him anymore. What we did on the RFID card, we disable the card if you are red. So I don't need to deploy people to check at the gate. So make them safe. Because if I have a security guard there, then that person will also become unsafe. So this particular person, when they're coming inside the gate, he was barred entry because it was a red risk. Okay. So this green, amber, red status became a real-time thing at the gate, and the panel will not move up because it is automated now. So we passed on that flag and made the flag red. So it will not move up. So the guy has to go back. Right. And the manager will know that now we have to intervene. So that is how this whole thing worked. Right. So, and it is still going on. We are finding so many applications of this connected people. Continuously, we are finding use cases and applications, right? Because once you have the data, you can just keep on the imagination, as you said, the sky is the limit.
Correct.
Right? So that is how it works. Yeah.
Thank you.
So our COVID response has been completely digital. And then when government would come and inspect. So there also, then we can show this is how we are managing. This is the data. And then we put all the data there. So it becomes audit friendly and all that stuff.
Another exotech trend that I actually mentioned in the introduction of in this series is the cloud computing technology. In fact, cloud computing technology is transforming manufacturing process in multiple ways. In the context of IIoT applications, or the Industrial Internet of Things, I believe that cloud computing technology significantly changes both the scale and scope of IIoT applications in manufacturing. Let's understand how. What is cloud computing? Well, as you see in the left side of this chart, traditionally, we understood computing as something that we have computers installed in our home or an office. An industrial business would have computers installed in their premise, and those computers, yes, to some extent, are connected to the network, for communication or sending information, things like that. But the primary computer is, mainframes or mini computers or personal computers. They're all in the premises of that business, right? That's how we understood. And they are on-site servers. All the information, kept within those computers. That is traditional way we understood computing. Well, a couple of decades back, the trend of cloud computing emerged, and fast as the high-speed interconnectivity and network, evolved. We now have what is, the capability called the cloud computing, where we store, all the computing resources, right? The data and the logic computing power is distributed. They're kept in remote servers in the network, and often called as a cloud. Cloud is a network of, high-speed computers. You actually kind of host your data and logic in these computers, and they're often managed by third parties, Amazon or Microsoft and IBM, and they're all some major cloud providers, in fact, including Google. And what is this actually, what is the capability that it provides? By centralizing the location of your both computing power and the data sources, and that being situated in a high-speed network, ubiquitously accessible from everywhere. Now, this now provides an opportunity that you can access beyond your proximity. In other words, the computer doesn't have to be in your building, or in your home. You can actually access the information from anywhere that is present, as we all do when you log into Google and you search for something. You go to a website. There's nothing stored in your computer, but it's all actually in the cloud. This is a fundamental transformation because in various ways, and especially in the context of business benefits. First, there is a shift from ownership to access. Traditional computing, we believe that you need to own the computer, you need to have resources to kind of buy computers for you to have access to those computing capabilities. In other words, if you want to have access to a mainframe as a company, you have to own the mainframe, right? But that's not the case now. The shift is now ownership to access. Now, I could be a small company that doesn't have the resources to buy a mainframe or a powerful computer, but I can access the computing power of a mainframe computer in the cloud, right? And then I can also, when I access that, they actually charge me only for the part that I access and I use. In other words, instead of buying and owning these assets as computers, now you have access on usage-based pricing. That's a big change, because what that does is actually it democratizes the access to computing, because the access to this computing power that was not available for small and medium companies, now everybody can access. That's one big change. The second piece is the elasticity, right? When you put the cloud, then you're hosting these big computers, then you can actually keep scaling the power there because it's all in a central location and it is being accessed for multiple users. So in other words, the term is called elastic scaling because you can scale as you need. Today, this week I'm going to be doing some project. I need some high-speed computing. I can actually access that. And next week I'm not going to be doing any project like that. I could actually do with some small computing power. I could actually switch to that. So that's the elastic scaling capability that creates another huge opportunity. Now, how does it all connect to the IIoT applications, right? Now, if you think about when we define Industrial Internet of Things, we said we go beyond computers to connect all these different kinds of devices, or they are called things, right? They could be, your tablet PCs, your phones, your industrial machines that are used in manufacturing, your, simple sensors, right? I mean, you're kind of sensing, thermostat or whatever it is. All these are connected to the internet now, and then they're stored in a common place. Now, instead of storing them in a traditional way in a computer, if you actually start storing them in a cloud, what happens? Well, then it gives the capability, just we talked about, as in the case of thermostat example, all these manufacturing information from different machines, all these things could be stored in the central location of the cloud. Now, when you store it in the central location of the cloud, then that becomes accessible to anywhere in the world, right? I mean, so if you're a large manufacturing company with multiple manufacturing plants, then you could actually access the data, real-time data coming from these sensors and these devices connected to the Industrial Internet of Things applications, right? They can be accessible from anywhere. The decision maker, if she's either locally present or she's traveling internationally, she can still get access to all this information because it is now situated in a cloud and you can actually access through cloud, right? Similarly, since it is elastically, scalable, you could actually do this application in one plant. You can actually expand this into multiple plants as the kind of the size of this data expands or the kind of logic actually expands. So you can actually manage these applications directly from the cloud. So we'll talk later that you see that most of these IoT applications, Industrial Internet of Things applications are actually now more and more, rendered on platforms that are sitting in cloud, especially because of these, power that comes with the cloud computing. The another concept that you would have actually come across more recently, in the last few years is called edge computing. We call it, there's something called cloud computing and there's edge computing. Well, edge computing is nothing else but this external layer on top of the core cloud. Core cloud is the high-speed computers are connected. On top of this is this external layer. Now we connect all these different kinds of devices and things, as we call in Internet of Things. So they all have intelligence now. What is happening is that with the kind of miniaturization of processing power, and then and the Moore's law, you have more and more intelligence in some of these devices, and they are actually connected to the periphery of the cloud, and that's why they're called edge devices, right? And this edge computing concept is more popular now because now as the companies think about designing business applications on industrial Internet of Things, they have to make a decision in terms of what kind of intelligence would they actually kind of keep on the edge of this cloud and what will go in the core of this cloud. So there is an interesting trade-off in terms of what should be the intelligence in the edge and then what should be in the cloud as we design the applications for it to be more scalable and usable across different locations. In summary, we talked about what is cloud computing. We understood how is it different from traditional computing, the way we understood computing 2 decades back, and what has changed and what does it really mean to push all these computing power and data into the cloud. We also talked about the business benefits, right? How this cloud computing concept has fundamentally changed the economics of access to computing power and how it has democratized access to computing power. Then we connected that with why the concept of cloud computing is important from the context of IIoT applications for large manufacturing companies, why they need that elastic scaling capability for them to scale and manage the scope of their IIoT applications. And finally, we touched upon the concept of edge computing and the importance of balancing the intelligence between what should be in the edge of these applications and then what should be in the core within the cloud for these applications. Today, we have two industry experts who've got several years of experience working on IIoT technology across various customers in North America and Europe and across the globe. We have Mr. Anil Pillai, who's the lead solutions and consulting head for Industry 4.0 at Tata Consultancy Services. And we have Sachin Bhavsar, who works with Anil and is a senior consultant for Industry 4.0 at Tata Consultancy Services. So Anil and Sachin, welcome to the course.
Thank you, Professor. Thank you. It's our pleasure.
Yeah. Anil, maybe I'll start with you. You have, we all know about, TCS has been in this business for many, many decades now, and you've pioneered the digital transformation of manufacturing right from even before Industry 4.0. But with Industry 4.0, you have several engagements across, across the globe. So, for our learners, can you pick a couple of examples, based on your engagement with clients as a system integrator, in working on IIoT projects across manufacturing industries? So, do you share a couple of IIoT application projects that you've done?
Yeah, sure. Thanks, Professor. So, yes, I mean, we do have multiple examples of engagements spanning from developing, very foundational capabilities using IoT platform, as well as, advanced capabilities which are more model-driven, data-driven. So we have a spectrum of such use cases and capabilities delivered to customers. I will pick some of them, which are, quite diverse in the sense we are talking about multiple capabilities delivered through the IoT construct. And one example I take is with our European customer, which is they are into cement manufacturing, and they have a big program running in wherein they are trying to move to a very data-driven operations. And when I say data-driven operations, they are talking about multiple data model-driven capabilities being delivered to business. Now, these are capabilities which are helping them in improving the reliability of the assets, the critical equipments that they are using at the shop floor. This includes process-related capabilities which are helping them predict quality issues. They are using this to avoid certain events in the process. So we are delivering for that customer various capabilities using the IIoT construct. So let me take one example from an asset reliability standpoint. right? So the customer is having multiple critical equipments at the process level, right? And any downtime associated with this critical asset directly impacts their production, right? So the first thing they are asking to implement is the ability to get a view on the health of their critical assets. So these critical assets are crushing mills, roller mills, right? So the first thing, from an asset standpoint, the capability that we are helping them realize is condition-based monitoring and predictive maintenance, right? So let me explain those terms, right? So we are talking about how we can use the historical data of the asset and model the asset so that we can use that model to predict upcoming deterioration, right? So the way we have conceived the solution is we conceived a health index for that asset, right? And as data starts coming in from the real-time sensors at the shop floor, the model will help us get a view on the current health status of the mill, right? Now that is helping the operators, the production supervisors to get a view as to how stable the current operations are, right? Second thing we are building for them is the ability to forecast this index for the upcoming days, right? So basically we are using data analytics, data-driven model to forecast this index for the next coming few weeks, right? So that they can see how stable the mill is right now in the current operations, as well as they get a view around how this would be in the coming days with the historical data that we have used to model the asset, and that model being fed with the real-time data coming in from the sensors. We are able to also forecast this index for the upcoming weeks. Now this has very successfully been deployed in one of their plants, and now as we speak we are taking it to multiple other sites for the customer, right? So that's one example from an asset standpoint. Now, from a process standpoint, the same philosophy that we are using historical data to kind of completely simulate the behavior of the process, right? So in this example, there is a preheater, which is again a critical aspect of cement manufacturing. So what we are doing is, again, historical data of the preheater operations has been analyzed. And with that historical data, we have developed a model which again will alert an operator if the process parameters deviates and it sustains for a time. Then the model will predict a blockage, right? And any blockage that impacts the production. So it's like they may have to stop the operation because of the blockage, right? Now the system is predicting that blockage much in advance so that the operator can take the corrective action to prevent it or avoid that blockage, right? So that's another example. Third example is, using image analytics. We are also helping them with correctly monitoring the quality of the cement that is produced, right? So these are some of the examples of how we have applied these technologies, and given the scale of operations they have globally, with the successful deployment at a pilot site, now we are taking it to other sites. We are taking it to other assets. So we started with one critical assets. Now we are expanding it to other assets, right? The other mills and other kiln and other, right? Even from the process standpoint, we are taking it to other process challenges that they have. So that's one interesting case wherein we are engaged with this customer.
That's very comprehensive. So you kind of you covered asset health monitoring, right, and kind of almost like a preventive maintenance for the assets, right, and then any process deviation. Plus the third one you mentioned is also quality applications, where you actually potentially are using IIoT to test the quality of the end product as well. Correct?
Yes.
Right.
Yes.
We know that the focus of this course on the business applications of industrial Internet of Things technology. But in order to further understand the business context and how it's applied, I think it is important for us to have some understanding about the technology and the technical concepts behind how these applications are created. You need to understand, you need to build awareness about the building blocks that actually lead to these capabilities. And more importantly, the players, the different companies that come together and play different roles in developing and delivering these applications. So let's first start with the basic requirements. Like, you should never think about any IoT or IIoT applications unless you have your infrastructure right in terms of your hardware, your communication technology. Because just remember that all these applications that we talked about, some examples we used, they all rely on a good communication network that is high speed, that's got good latency, and so if you have problems with that, I think then it's going to be these applications are going to fall apart. So it's important to have the right hardware and the good communication network. And more important to that is the cybersecurity, right? We'll come and talk about cybersecurity is a big risk. You have to protect these applications, okay? Because on one hand, you get the advantages that you get real-time data access and you're able to make fast decisions, but at the same time, now the data is in the network. So you have to make sure that you have all the cybersecurity steps taken for you to kind of launch any of these applications. Then on top of that, what I call is there are IIoT platforms that are available commercially. Like we have MindSphere from Siemens is one of them, which allows for the gathering and organizing of data and the logic and the different pieces that actually pull together these applications. And there are multiple platforms that are available in the market, and it is important to understand what the variety of platforms are and what their pros and cons. On top of that, then you have these platforms actually also connect with the enterprise software, such as the ERP or your PLM software, the product lifecycle management software that actually runs the manufacturing process. These platforms connect with those software products. And also in a manufacturing context, you may have multiple devices, you have machines, and then a lot of these machines themselves are intelligent. And we talked about programmable logic controllers in machines, because the machines have ability to be programmed and they have logic in them. So those machines will have operating systems, right, or software that controls those machines. So we call it as device operating system. Any device, whether it is just like our phones has got an operating system, is it not? We have we call this as Apple's phone operating system or Android. These are operating systems. These are software that control the device. So just like our phone, we have other devices that are used in the manufacturing context. They will have their own operating system. So these platforms, they actually connect with those operating system software. And so with all these capabilities, on top of that, what you build is the IIoT applications. In other words, any of these, say, preventive maintenance application that I was referring to earlier. So that particular application, they will connect with the device operating system of that particular machine. It'll connect with the IIoT platform that you've chosen, so that how you're organizing the data and the logic, where you're storing it and which cloud architecture and things like that. And then it'll also, that particular software or the application, IIoT application, sometimes may also connect with your enterprise software. So that set of connectivity that I talked about with this platform and the device operating system, that is what leads to the IIoT application. Of course, this entire application is sitting on high-speed communication network that you've kind of architected, and we're also all protected with the cybersecurity software layer that actually protects this vital information. And of course, more recently, what has happened is the entire IIoT platform, they've been kind of moved to the hyperscaling cloud architecture, because now with companies like Amazon AWS or Microsoft Azure or Google Cloud, they all offer what is called as hyperscaling, because their ability to scale is enormous, in terms of they can take us, a manufacturing company from one single plant. They can connect the same application, give access to that application across multiple plants globally, so they can scale it the way they want in terms of both global access and also in terms of computing power. So that's why you would find that most of these IIoT applications are now kind of rendered from these hyperscaling cloud platforms, and these IIoT platforms are in fact hosted in those the cloud architectures. It is also important for us to understand, who are some of the major companies that actually are playing roles in various layers, as I have kind of showed in the diagram here. I mean, you certainly have appliance and hardware manufacturers. Siemens is actually both a hardware manufacturer and also a software, manufacturer, because it actually they provide both. In fact, they're very well known for their platform MindSphere that actually connects, all different IoT applications and also more complex applications using the IoT, capabilities. You have companies like AdLink that actually connects, to your the balancing the cloud and edge, intelligence distribution that we talked about earlier. We have, specialist companies like Fastly, which actually kind of provide this edge computing platform. We have NVIDIA, which is actually a chip company, which is a very, very dedicated, GPUs, graphic processing units, or, high powered, very fast chips that are dedicated for particular applications, so that you can put that in a specific edge application. So there are chip companies that are playing here. There are system integrators, right? Like Accenture, IBM, or Tata Consultancy Services, Deloitte. All these are what we call them as system integrators, in the sense they work with multiple platforms and they actually bring together all these different parties, and they take ownership of working with their clients to kind of deliver this IoT application, in the context of that particular manufacturing company. And some of these, system integrators, more recently, they also have their own platform, like TCS or Tata Consultancy Services. They have their platform. IBM has its own platform. So that when you're developing applications, sometimes they also can bring their platform. And of course, the hyperscalable platform that we talked about earlier, Amazon's AWS and IBM's platform for IoT, which is also kind of rendered from cloud and Azure. These are some of the examples of how different companies come together. The reason I'm actually sharing this is when you are learning about these industrial Internet of Things applications, it is important for you to know what goes with behind the screen, and then how these all come together. Because for rolling out or thinking about new applications, it is important to understand who are the players, who are the partners, and then how do you make use of these partners to kind of build a viable and scalable solution for you. So Anil and Sachin, I think TCS is an interesting, position. It's an interesting position in this IIoT application evolution in the industry, right? I mean, TCS has evolved more as a systems integrator, doing a lot of custom project, around these the manufacturing, first enterprise systems, then the operations technology, and then bringing these things together as IoT application. But more recently, I also learned that you also have your own platform, right? In terms of building an IoT or a digital twin kind of a platform where you connect these pieces together. Tell us about that journey, and also give us a picture of how you see this ecosystem evolving.
Sure. Yeah. So yes, I mean, IoT as a space is definitely, we have so many players, right? And when we talk about capabilities enabled through an IoT platform, it is not just limited to the IoT platform itself. For example, if I were to talk about a capability like predictive maintenance or optimization, it calls for components that will come right from the foundational layer, which is identifying the right sensors that can give us the data, identifying the platform on which this application will be built, identifying the right components that will be used for the development of analytics algorithm, right? So whenever we talk about any capability being realized in this particular space, there are multiple players that come into play, and TCS, I would say, depending on the various engagements that we have and the specific customer needs, we are engaged with customer where we are purely a system integrator, bringing in the capabilities that are required to build this kind of application on a customer chosen platform, right? So that would be one of the examples of our play. Second is where the customer is also looking at recommendations and support in identifying the other components, right? So it could be technology evaluation with respect to sensors. So we help customers identify the right sensors, identify the vendors who can provide those right sensors, help them evaluate the different technologies, the different components that come into realizing this kind of capability. So the other aspect of our involvement is not just limiting to developing those capabilities on a chosen platform, but helping customer identify the right platform, identify the right vendors who can supply those different components, to build those capabilities. Third, I would say, yes, I mean, we do have our own platforms, wherein, depending on the specific customer requirements, we do position our own platform as well. And these are, platforms which are specific to meeting their analytics, data analytics needs. These are platform requiring IoT construct, capability construct kind of platform, solutions that we have from TCS. So it depends, and I would say we are engaged wherein we have examples where we are purely a system integrator, player. We have examples where we have our own platform being used by the customer to realize this capability, and we have a broader ecosystem play wherein we bring in the right vendors from the ecosystem, whether they are supplying us with the right sensors, with the right cameras, and as required. I mean, depending on the specific use case needs, we play a bigger role in kind of bringing in the other players to help customer realize the capabilities.
IIoT technologies are called as one of the primary drivers in Industrial 4.0 because the enormous business opportunities that they bring in terms of how manufacturing companies can deploy these applications and create value for customers or manufacturers, suppliers, all the stakeholders in the manufacturing ecosystem. In fact, as we talked about, if you bring together high-speed connectivity and then embedded intelligence in these devices through software, and also the ability to connect these devices and then build these applications on cloud platform, hence enabling this ubiquitous access, I think it just leaves imagination as the only limit in terms of what companies could do. Putting all these capabilities to create applications that deliver business value. We are, in this segment, we'll talk about maybe about 5 dimensions of how IIoT applications can deliver value to manufacturing. But these are just, starting point. These are just some, 5 dimensions. In fact, beyond this, as I said, imagination is the limit in terms of how you can further build these applications. So, as you see in this chart, I've kind of captured, the 5 dimensions in terms of, benefits from IIoT applications in terms of improving the manufacturing productivity, in terms of improvements to quality, cycle time, and of course, safety and compliance. And last but not the least, the customer experience itself, right? Your IIoT applications can actually deliver on all these dimensions and more. We'll talk about it. So let's talk about productivity first, right? As I say, in these bullet points, basically with IIoT applications, you can connect assets and processes to kind of dramatically improve the utilization of capacity, utilization of the assets. Let me give you an example, right? One of the large manufacturers in an emerging market, they had almost it's a mining and a cement manufacturer. They had almost 8,000 dumper trucks in just one location, one segment of the market. 8,000 dumper trucks in operations and with multiple projects, and but at the same time, where they were actually kind of facing challenges that they were not optimally utilized. There'll be more trucks in the place where they are not actually needed, and there'll be they may not have the dumper trucks in the place where they're really needed, right? So they just simply created an IoT applications by tracking the movement of all these dumper trucks, right? And capturing and building this application to be accessible from cloud. So what does it do? And actually it gives real-time visibility for all these, trucks. And also they can, through complex sensors, they can not only track the location of the loaders, but on the dumpers, but they can also see how often are they used. Are they used to full capacity or not? All these different kinds of information you can actually capture through these IoT applications. Now, when you put all these things together, then you can, instead of some managers maybe could optimizing it locally in that particular unit. When they get the information about capacity utilization of all these thousands of dumper trucks, they could actually then pool that in a common place and better allocate the resources. In other words, these applications allow you to reconfigure the resources so that you can improve the capacity utilization. Similarly, you can actually kind of proactively identify some problems. And say, for example, if there is a process in the manufacturing sequentially, and through IoT applications, if you can actually sense maybe a deviation in a particular machine, in the upstream process, then you can actually, if you catch that error, then what you've avoided is that, those kind of parts moving in the downstream with that quality problem. So it kind of both attacks your quality benefits and, of course, reduces the rework and comes back to your productivity benefits as well. So going to the quality, now we just talked about some of the quality benefits, but in quality, the IIoT sensors application, they can actually kind of they can limit the manual intervention, right? In fact, a lot of times there are machines that are actually kind of, where precision is very important, and sometimes when there is manual intervention, there's automation of some of these processes can actually kind of, either completely eliminate manual intervention, or they can guide the manual intervention so that your reliability goes up and the possibility of error comes down. Sometimes the machines are calibrated and in a way that you can actually, you can get the real-time process operating metrics, right? I mean, it is often called the PQ charts in a manufacturing context, where the parameters under which the process of a machine operating should be within that range. And if there is any range that is actually deviating from that, then you can have IIoT application that actually can capture that information at a central location. They can immediately, the manager, she can take an action either to stop the line or make any corrective action so that there's no downstream, kind of wasting of resources, and hence that will actually improve both not only the quality but also productivity and cycle time as well. Again, in the context of cycle time, you can if you can anticipate the problems, then of course you're reducing the rework, and the overall cycle time gets reduced. You can you can take this not just within your own factory. You can actually take it beyond your factory in the upstream suppliers as well. Sometimes, in a hyperscaling cloud architecture, some large manufacturers even actually mandate that some of their suppliers connect to their IoT platforms and provide real-time information into that IoT platform in terms of what is happening in the supplier operations, or when is the next dispatch going to be happening, or if there are any quality problems in the supplier operations. If they get to know that information proactively, then obviously they don't have to block some of the resources for that defect part that is coming in, because that's going to be stopped now, it's going to be rerouted. So they can now deploy these resources in a different place and then improve the overall cycle time and productivity. But similarly, IIoT applications are also used in dynamically configuring some of the machines, right? We talked about, the PLC controllers and how they actually automate the machines and they actually program the machines. You can actually connect that with IIoT applications where you can actually sense changes happening in the manufacturing process. You can reconfigure the machine to kind of be ready for a new set of operations, kind of promptly to any other changes that are taking place. So that automatic reconfiguration of machines can actually significantly reduce the typical management latency time where somebody reports this problem, they discuss the problem, and then addition is taken. So this all could be automated through IIoT applications and hence shrinking the overall cycle time. Of course, safety and compliance, there's so many applications, in an industrial context. You could be, chemical dangerous gases that could be sensed. It could be, you may want to, geofence some places. You may want to track people don't get into dangerous locations. And, in an emerging context, sometimes, you have trucks, your supplier trucks or your, outbound logistics truck. They're come parked outside your factory. Sometimes they may not follow the discipline, like, in terms of where exactly they're supposed to park. And that could actually kind of, raise the risk of safety as that for not just manufacturing organization, but also the economy and the society around them. So they can track those trucks. And in one application, I know they want to make sure that these truck drivers are disciplined. They actually, park the trucks exactly in that location. They use IIoT application to make sure that safety norms are followed, not by their own, the trucks and the drivers that they own, but actually they may even contract freight operators outside. So they actually kind of enforce the discipline on those freight operators and the trucks that they bring through this IIoT application. And, so this kind of, increasing the visibility can lead to a lot of applications related to safety and compliance. And last but not the least is, as I talked about, we can actually go to customer experience. Now, IIoT applications are the starting set of capabilities or technologies that actually can take a manufacturer, closer to what we call as a lot size of one. If you recall in the introductory section of this series, we talked about the demand from the market, is all about because consumers are more informed and they are now demanding what we call as the N equal to 1 sample size of 1 personalization. And we heard from our industry experts and Siemens and other companies that how they are seeing those demands coming from the consumers for personalized experience in the product. And that is coming into the manufacturing operations as what they call as the lot size of 1. Now, that lot size of 1 capability is not possible without having some intelligent IoT applications put in place. For example, you could actually kind of put sensors in the products that the customers are using. You can get a lot more information. You can enrich the customer engagement through that, and then better monitor the usage of the product. And that can actually also enable personalization, because not just this passive information that is collected, but you could also have some intelligent on the edge of the products that are being used by the customers. That will increase, ability for the manufacturing firms to engage with the customers. Similarly, visibility in the macro customer trends, right? For example, what kind of features are being used? What is it that the customers are wanting? In fact, they can these sensors, the technologies, in the customer premises can also help the manufacturers to understand the broader trends in terms of where the customers are interested in, what kind of features they're using. Similarly, like, as I said, these are just the, 5 dimensions I picked. We can go to, these IIoT applications, in fact, make the manufacturers more green. They are the environmental sustainability of the manufacturing operations can significantly improve by intelligent application of IIoT application, right? For example, they could actually sense, any of these, hazardous gases leaking. They could actually control the carbon emission that is kind of, footprint of that particular manufacturing unit. And they can program and redesign the operations, collecting the right information to make sure that they are not kind of deviating from any norms of the carbon footprint that has been designed for that particular plant. And that's possible. And in fact, we will talk a little bit more later as we go into advanced IIoT applications, which enables manufacturers to, look at the simulate the implications of the design of the plant, and hence the implications of the carbon footprint in terms of the design decision they take. So IIoT applications can also be used in that context, both in terms of design and also real-time monitoring of the carbon footprint in the manufacturing unit. As we discuss the enormous business value benefits that are possible from the IIoT applications, you may think that it's kind of the business case is no-brainer, and manufacturing companies are churning out these applications in numbers, very easily. However, that's not the case. Rather, if you look at the success of some of these IIoT applications, the initial stages, they're rather mixed. In fact, I find that there are two primary reasons for that. First, companies often get overwhelmed with the complex process that is involved in putting these applications together, right? Sometimes they kind of underestimate that complexity. The second, the technology by itself and the connecting pieces could be overwhelming for them, to kind of put the change in the organization through this new visibility that comes from these technologies. I believe that companies need a very disciplined approach to how they execute this project. Here, we present a simple 6-step framework for implementing the IIoT technology. The first step is to identify the problem area. Companies need to choose the problem that they're trying to solve and the value they're trying to create with the IIoT technology. And that choice has to be made in an intelligent way so that it ensures the success of the project. Second, they need to build this capability that is required for IIoT applications. It is not about just one project. They need to think this in terms of set of projects and what are the capabilities and the talent they require, and they need to prepare for that. Third, they need to identify executive sponsor who would be kind of behind these technology and applications, because when you roll these applications, there will be more complexities in terms of the change that you're bringing to the organization, and hence you need that continuous support from an executive sponsor. Fourth, companies need to align the different compatibility needs that are there in terms of the incumbent architecture, the incumbent capabilities that they have before starting these IoT applications. Then in the fifth step, they need to identify the partners that they will bring into this project. If you recall, we talked about the ecosystem of IIoT architecture. Who are the different kinds of players who come in place? So they need to kind of work and identify the right partners here. And finally, they need to prepare and execute. In other words, as in any other technology application, this requires change management, because you are actually expecting to change the behavior of people who are going to be using this new data. They're going to be looking for opportunity to optimize and improve business process. But unless you have a methodical approach to kind of manage this change, it is not going to happen. So let's start with the first step of identifying the business case. I think it'll be helpful for companies to start with a broad survey of the different problem areas that they're seeing in different units in the manufacturing organization. And so that they can prioritize, identify what are the collect a set of problem areas that they may want to solve, and then probably prioritize based on feasibility of execution, the business value benefits, etc. The specific problem or the business case that they are actually deciding, they also need to think about scalability as well. Because a lot of times the problem could be kind of particular to one particular unit, and you may want to select a problem where you could do a much bigger impact, because not at the pilot level. You can show it at the pilot in one plant. But then if the problem is such that you can take it to multiple plants, certainly the business value will be much higher. And finally, select the right site, because it also depends upon where do you start. You need to have all the support for that particular pilot to be successful. Building capabilities is the second step. Companies need to see this IIoT application capability as not as one piecemeal of each project, but they need to understand the set of capabilities that are required, whether it is hardware, whether it is software capabilities, it is the ability of the talent to understand the real manufacturing challenges and opportunities for improvement. All these things come together. In fact, it may be a good idea to build the set of core capabilities and also think about creating a center for excellence. Because once you set up a center for excellence, it is not about just the physical center. It may not be a physical center. It could be a virtual center. But the primary motivation there is then you're now able to pull the learning across different IoT applications into one place so that you can kind of deploy those learnings into the future applications as well. The Center for Excellence also allows you to capture different initiatives that are happening across the manufacturing unit because sometimes that transparency may not exist. Third is the selection of an executive sponsor. It is very important for any of the IIoT project initiative to have an executive sponsor because often these projects, they actually first require cooperation from multiple units. For example, if you're putting rolling out an IIoT application, putting sensors in a machine and then proactively tracking the operation of that machine, then you may have to, it's not just about putting the sensor, the technology piece often becomes easier. You also need to prepare your existing, workforce for that change because often it is a social change, it is a mindset change that is required. So you need to think about, and so in order to get all this support, that's why the executive sponsor is very, very important for you to handhold and do this change, successfully. And of course, the executive sponsor that you choose has to be knowledgeable and should be a champion of this technology. Then you need to align. Well, this alignment goes in multiple, levels. First, you have to align with the technology infrastructure needs. Now, depending upon who you are as a manufacturer, you could be an incumbent manufacturer. That means, these large manufacturing companies already have legacy machines. They are machines purchased over many years, right? And those come from different vendors, and there may be some compatibility issues of connecting these machines or putting sensors in the machines. So you need to look at these compatibility and the integration challenges. That's where you need to kind of connect this alignment with also the choices that you make in terms of what platforms should you be choosing. Now, when you think about the platform, then the partners that you bring in, then you also think about like what kind of changes are required. Then you have to kind of do some kind of an optimization there because you're weighing the complexity of change that you're enforcing on the existing process and is it feasible or not. And of course, then you have to define how the new process will operate. You could check the new process before even implementing whether it's kind of viable, both from a technology standpoint, from a social standpoint as well. Then, of course, you go back to your partner ecosystems. As we discussed in the infrastructure of IIoT technology architecture, there are so many different partners. There are industry vendors who actually kind of specialize in bringing IIoT platform, an integrated platform that you can use and build your IIoT application. They're platform owners. There are, of course, cloud architecture providers that you need to work with them to hyperscale your application once it is successful. You need to deeply understand the devices that you're planning to connect and what kind of restrictions those devices have and who are the kind of systems integrators or other partners who would have expertise and experience connecting those kinds of devices. And of course, you also need to then put a change management program in place. Remember, this is a bigger change socially than technically. Of course, technology compatibility is a challenge. You need to tackle that working with the right partners. But then those are external partners. You also need to bring internal partners because that's very, very important. In this, IoT applications or any of the Industry 4.0 applications, what I've seen is that one of the biggest disconnect that happens is the disconnect between what I call as the operations technology and the information technology. A lot of times the information technology, right, the ERP systems and the enterprise systems, they're all owned by the CIO office and the IT organization of the manufacturing unit. Whereas a lot of these IoT applications and then embedded intelligence in processes and machines, we call them as operations technology. So you need to bridge this gap well. And that requires making internal partners, like whether it is the IT organizations or it is the shop floor users who are going to be using this, the new application. And they have to kind of be ready to change their behavior, their operations, with the new technology. So hence, you have to kind of prepare for that change management. And so finally, execution. In order to execute successfully, certainly you have to follow up with the training I just talked about, right? You got to train for the new change that you're putting in place. And it's both a cultural change and also a technology change. So you need to kind of plan for that. You roll out the pilot project first. You focus on pilot, and then that's how you execute. You roll out the pilot and also evaluate the outcomes that comes from the pilot. It is important to do the pilot because you often learn a lot in that pilot. You kind of work out the kinks, you see what worked, what didn't, and then I may have to iterate a couple of times for the pilot to work. But once you have the business results in the pilot, then make sure to celebrate that and communicate, because this is more of a social change. It's more of a behavioral change as much as a technology change. I mean, I would like to emphasize that the digital transformation of manufacturing is not just about technology, it is also a cultural transformation of the organization. Hence, it is important to celebrate, recognize the people who contributed, and also recognize the people who are changing their mindset, their way of behavior through these new applications. And finally, once you achieve this, then plan for scaling so that you can take this specific application from this one manufacturing unit to more units and more plants so that you can amplify and multiply the business benefits coming from this application. In summary, so this framework talks about the 6 steps of identification of the problem area that you want to solve, building a set of capabilities, maybe through a center of excellence for industrial Internet of Things, and then working with an ecosystem of executive sponsors, right? You need to get an executive sponsor for each of the project to make sure that particular project is successful, because that requires continuous support, and it requires that that air cover from the management for this project to be taking off. And of course, you have to align with the specific technology needs, incompatibility that you may have, because depending upon who you are in terms of the manufacturing industry, whether you are an incumbent or a completely new organization. Look at what the infrastructure you have and how do you need to align with that, and also look at the external partners that you bring in. That's the next step, is who are the external partners? What platform are you going to choose? Why are you choosing those platforms? And then what kind of partner network you need to put in place, bringing together your platform providers, your system integrators, your internal partners, your technology IoT department, your workers who are going to be impacted, management decision makers who are going to be impacted by this application. Build this ecosystem and make sure they are all convinced, and then start this change management process, very effectively. Finally, the execution, where you're actually kind of putting the pilot in place, showing the proof of concept, showing it working, and you're kind of correcting it to make sure that the business value results are out. Then you're communicating and closing the loop. As in any technology applications, the IIoT applications also come with both risks and challenges. There are challenges that companies are likely to face when they think about this opportunity to use IIoT applications in their manufacturing processes, and it also comes with risks. So let's understand both challenges and risks so that as we can build this awareness and make sure that we implement this to ensure success of these applications. Now, the sources of challenges are multiple. I've just captured 3 of them here, and then we'll start with first technology compatibility, right? I mean, as I said, the challenges that companies face from IIoT technology applications, in implementing this depends upon who the manufacturer is. For example, the challenge is going to be different if you're an incumbent company in the manufacturing industries, let's say auto industry, and you've been in the industry for many years, and then you're trying to kind of transform with IIoT applications. The challenges you face is going to be different from challenges faced by maybe a new entrant into the manufacturing, of auto parts or auto products, say, for example, Tesla. Because the new organization actually have the advantage of starting with clean slate. They will have probably new machines, they have right interfaces, they have have the kind of power to make those decisions while thinking about those IoT applications, right? Whereas an incumbent companies may not have that choice. They already are having a legacy, technology architecture and then machines that are from multiple vendors. So they need to find how to work across these compatibility challenges. And that doesn't mean that it's not possible. In fact, a lot of times, I'll come to the risk piece, because sometimes companies think it is very overwhelming and they don't, get a start at all. And that's not how to operate this. But to understand these challenges coming from these compatibility issues and then manage those. The second challenge that often comes is the variety of devices. Again, You may want to scope, as I talked about in the implementation framework, you have to scope the IoT applications initially to kind of limit the kind of both the variety and the volume of the devices, because both these actually bring complexity to the application, and the variety of devices, of course, certainly increases the business value, the potential of what the application could do. But even if you want to include a lot of variety, then you may want to do it in a phased manner so that you ensure success. The third and a very important piece of the challenge that we see in these projects or in this initiative is the sourcing of the right talent. Manufacturing organizations traditionally have not thought about talent in this way as it is required in either IIoT or other Industrial 4.0 applications, because a lot of times manufacturing organizations looked at an engineering skill or maybe process management skill, supply chain skill. That's how they've looked at. But more and more of these in IIoT applications, or in any other technology that we'll talk about in this series, you need a talent pool that comes from multiple disciplines. You need a problem-solving team that pulls together engineering talent, pulls together business talent, HR talent, of course, problem-solving in the operation process context. You need to put all these things together and then overlay on top of that, of course, the software ability to kind of, to kind of develop this software and execute the software projects, and of course, connectivity between hardware and software, the core technology knowledge, that's also important. So companies have to kind of understand this challenge and then think in terms of how do they form the team. In fact, I talked about the Center for Excellence in the earlier segment, because that's very important. You cannot assume that your current existing workforce are completely aware of this change that is needed, and neither can you kind of discard the current workforce, because you have to work with the current workforce. You have to reskill them. You have to identify the new talent that is required, and then you can combine and form these teams. Those are the kind of sources of IoT challenges. There are many more. I just captured 3 of them here. Now let's go to risks. Again, there are multiple risks that you could see in the IoT projects. First, actually, I'll start with cost. A lot of times, cost can be risk on both sides, right? Sometimes, companies actually kind of are too overwhelmed by the complexity of the project, and they think that it's too expensive and never, get a start. That's one side of the risk and cost. The other side, and in that risk, they actually lose the opportunity, right? And that comes with these applications. The other side of this cost risk is sometimes, these, if they're not scoped well, these projects actually can kind of keep expanding, and then, that can actually lead to cost overrun. That's one risk. Cybersecurity is a very important risk. The next risk is cybersecurity, because, remember that you are exposing the data through these applications, and it is important to contain that through the right, cybersecurity software, right, management and governance principles for cybersecurity, and all those have become very, very important to mitigate that risk. Ability to absorb data. What I really mean by that, I referred to this in the implementation framework as well, because you don't understand that companies need to kind of recognize this is not a technology change. This is a social and behavioral change as well. And this is a change to solve a business problem. A lot of times companies may actually get overwhelmed by the quality and the quantity of data coming from these applications, but they may a little bit fall short in terms of how that data or information is used for effective decision making, right? I mean, the kind of actionable insights that I talk about, in the framework. So that is missing. So it is important for the real value and the benefit to come up is to ensure that the business processes and the decision making processes are changing, and you're realizing the business value to kind of bring it back. And for that, the last piece of the risk is so important, because leadership and change management risk is very kind of connected with the previous one about the ability to absorb data, because that behavioral change has to first start at the top of the organization. The executive sponsors and the leaders of the manufacturing organization need to be kind of completely bought into this, and they have to give a lot of support for this to take off. Because what I've seen, or in my experience, is that, once these applications, they catch the momentum, when the organization starts seeing the benefits from these applications, then it just kind of starts rolling on its own, and then you get the momentum, and then the culture starts changing within the organization. For that, it is important both from the leadership standpoint and the change management process that is put in together to ensure the success. That is about communication, it is about recognition, it is about kind of taking the entire team along as a participatory team so that as a collective success is announced. Kathleen, can you share with us, based on your rich experience in this field, what are some of the challenges that your customers face when they try to roll out this technology? In other words, where do things go wrong? What is it that they should be careful about? And also, what are the embedded risks that are involved in rolling out an IoT technology in a factory?
This is a great question. What are the challenges and risks when you're building an IoT solution or an IoT platform? It seems simple when you first start talking about it, but the more deeper you get into the problem, the more complexities that you face. The first challenge is that every device is going to look different, and they all communicate on different protocols. And so that becomes your first challenge, just figuring out how to talk to each of the devices and how to collect data from them when they all literally speak different languages. In addition to that, a lot of these devices, they don't have a lot of compute power. So you have to be able to get them to connect and share data. And they might just be, a very, very small processor. They might be an industrial PC. They might be a microcontroller. It is a very diverse world. And that is the first challenge that you have to face. The second challenge is, how do you collect data from those devices, authenticate those devices, and securely transfer data to whatever point your internet is? Whether it's a cloud, whether it's an on-premise system, there's usually a central point where you're having your devices connect to. So doing that securely is very, very important because you're dealing with potentially sensitive information, sensitive data. So getting your security right is key. Another aspect is, how do you process the data in real time with a disparate set of devices that are all connecting with different sample rates and at different speeds and different velocities, and making sure that you have a robust, scalable system, because you want to be able to make decisions on that data stream. You may want to make decisions in real time, and those decisions might be critical to your business. So you never want to lose any data, and you want to make sure that the latency between the time that you collect the data point and the time you can act upon the information that the data points give you, you need that latency as small as possible. So diversity in your devices, in your data systems, in your communication protocols, security, and doing this all in real time without losing any data, and making sure your systems are scalable and resilient. Those are the keys to really getting it right. And there are so many technologies and so many complexities that it really is important to understand your use case, understand the constraints on your problem, understand the limits you need to have in place so that you can address all of these different challenges for your different business cases.
Based on your experience, as TCS, working with so many clients over decades on these applications, if I ask you to pick, which are the two major challenges or risks that you see that companies often face based on your experience?
Sure. Yeah. So yes, I mean, while we do talk about the adoption of these technologies, within the manufacturing context, we do have a lot of challenges, and at times this challenges becomes actually the reason for those not scaling up. There's this IoT initiative within manufacturing not scaling up. First, I would say is the very reason why this technology is being applied to a certain challenge, right? So let me take an example. By that, what I mean is we have to identify a specific manufacturing or a business problem statement that can be solved with this technology, right? Typically, it so happens that there is a technology and let's see how it can be applied. I would say it has to be the other way around. There has to be a specific business or manufacturing challenge that should be looked at as a candidate that can be solved through this technology. And again, I mean, in our approach as well, the way we approach this is we try to understand what is that particular problem. This could be related to, reliability of the asset. This could be related to improving the yield or soft sensing the yield for a process. It could be improving the throughput from a line, right? So it could be various different, challenge that we are trying to solve. So first thing I would say is identification of the problem statement that can be solved through this technology. It has to be that we clearly understand what are we trying to solve. That's one. Second is creating a value or deriving the value that solving that problem will deliver to the business. That is equally important, right? So we have to see how much of an impact this application of technology will do to that specific problem statement. So this being the first challenge. Second challenge I see is with many of our customers, it has kind of led only to a pilot implementation or a proof of concept kind of thing. It has not scaled out beyond one plant or one pilot case.
Why do you think that is the case? Why do you think that is the case?
That is the case because again, we are trying to solve something which doesn't have that much of a business impact, right? So we strongly believe that the impact has to be there, not just for that plant, right? So the value comes when we multiply that across multiple sites, multiple lines, multiple factories, right? That's where the cumulative value gets realized, right? So the second challenge I would say is, many of the initiatives are still stuck at the pilot level. So either the business is not seeing a value with the pilot. This is one of the cases that we have seen that, we have done a pilot which is very successful, right? Successful in the sense it has, the technology has been proven, right? For that particular use case or that particular challenge. But the business is not seeing a value, right? In that particular capability, right? So that's something kind of, reduces it to a one plant or a one pilot case. The second being not factored the architecture in a scalable way, right? So we have proven it here. Now we have to scale it to multiple sites, right? And that's where again the aspects of conceiving a reference architecture that can equally apply to the variations that exist across the plant, the variation that exists across the underlying IT and operational technologies that are there in the plant. So that would be the second challenge, I would say, not factoring those in conceiving an architecture which can be
Very good, thanks. So basically, I mean, you summarized it very well in terms of the business case issue, right? I mean, clarity of the problem that's being solved and the business value behind it, right? I mean, the first is the business case. The second is having the foresight to make sure that there's scalability in terms of infrastructure is kind of portable and scalable. So those are the two places where they have the challenges. So, Sachin, do you want to add anything to that?
Yeah, I think that's a very practical question that we are trying to address here. And one of the notions that the operators formed during a IIoT program is they feel that this program is for reducing manpower, right? Which gives you resistance from them to implement the solution and to effect the changes that you want to do. Now, which is not so. So the notion of reducing manpower through an IIoT program is totally wrong. The objective of an IIoT program is to gain productivity benefits by empowering the workforce with additional intelligence. right?
Got it.
So
Okay.
it is very important that we are empathetic while embarking on such a program. And the design of the program and the solution has to be extremely human-centric. It cannot be, it has to be human in the loop while designing the entire solution.
That's a very good point, Sachin. Thank you. Thank you for sharing that. Yeah, thank you.
Change management becomes extremely critical in this kind of programs, actually.
As with any other digital technology, both the scope and the capabilities of applications using IIoT is also expanding fast. If you look at the future trend of what's in the cards, like how companies are now beginning to emerge out of simple siloed IoT application to improve a particular process or so, now they are thinking about building the full visibility of supply chain end to end, from upstream suppliers to downstream, logistical partners and customers, so that they are not just looking at, information about a particular product, but the entire process and as much information that could be kind of made visible as possible. So that's one trend that we see. And we're also seeing more customized sensors for unique applications. And, we have sensors that are coming with, kind of powerful chips so that they have intelligence in them. For example, what we're also saying is that more and more dedicated sensors will actually look at, connecting not just the manufacturing process, but also, focusing on the talent and then operations of workers working in factories. For example, there are sensors that are kind of maybe sometimes put in the body of the workers to see what kind of movements they're doing, and then collect information from those sensors in order to, improve the design of the product itself to make it more ergonomic, and then, improve the strain on the, physical strain on the body of the employees working on the product. And those are some dedicated sensors. Now, talking about dedicated customized sensors, we're also now seeing sensors which are now more intelligent and are learning, right? There is embedded intelligence, thinking about, referring to the edge computing we talked about. There are, powerful chips within the sensors that actually, so that the sensor can learn over time. And we will talk more about when we refer to, or when we come to the section on artificial intelligence applications in manufacturing. We also have more, exciting applications in other industries as well. Now we're talking in terms of breath sensors, where, the sensor can actually kind of sense our breath and then probably, decode in terms of what kind of disease we have and how serious, how critical is it, is a problem that we have, and things like that. They're now talking about micro sensors, like, where there are possibilities that, these are all in the works in the R&D, where there are possibilities of putting micro sensors in blood vessels to, kind of measure the blood pressure, right? Right now we measure the pressure from outside. Can we do it from inside? That's the real-time data, right? As things happen. So these are some of the examples of where this sensor technology is moving. This broad spectrum of, some of the future trends, a lot more, because remember, this is fueled by the, advances in communication technologies, advances in, miniaturization and microsensors and, electronic circuits in terms of how powerful they can get. All these capabilities are coming together to kind of define what will be the future trend. And also, as I see from being siloed applications, IIoT sensors and what we call as the integrated manufacturing or the Industry 4.0, all these technologies, concepts coming together and connected through sensors, in a way that actually enhances the potential for the application. I think that's also another future trend, how IIoT will evolve as one of the threads that actually connects this platform of the future of manufacturing. So Anil, can you guys actually give us an idea, because with your rich experience in this industry, you've seen in the past, you've seen the present in terms of what kind of applications companies are, putting in place where we are. In the future, next 3 to 5 years, what do you see? What is the trend you see in this IIoT applications being used for manufacturing companies?
So one thing which we are seeing is the adoption is more in terms of making the operations more predictive, in the sense using the data that is being collected, getting the insights from the data, right? So the going forward, the operations will be more data driven for sure, and not just data driven, right? Now, with the kind of technologies and capabilities that this technology provide, it would move into the zone of applications prescribing a lot of actions to the operators, right? So it would be more in the prescriptive zone where the system is sensing a certain deviations, and in order to avoid either event, it is prescribing what can be done, right? So that's where we call the human in loop, where it could be in a recommending mode, where it is recommending a certain things to be done by the operator, or it can go to the extent of actually applying that on the control layer in the shop floor to the actual machines, right? The second aspect that we are looking at is also the ability to consider or digitize the knowledge that are there with the operator. Till so far, we have spoken about data coming in from the machines, data coming in from the different sensors, right? But the other aspect that we are looking at is also how we can use the tribal knowledge, the experience of the operator, also to contribute to this construct, the autonomous and self-optimizing construct. So that's something which we are focusing on, wherein we bring in the data aspect of it, and we bring in the knowledge that exists with the operator of having, they come with a lot of experience. So how that experience also can part of this solution construct.
That's very interesting. So basically what you're saying is that the human in the loop concept is very interesting. So these predictive algorithms, with the data, kind of informed, they are now empowering the human and then, to take better decisions. At the same time, there is a two-way street here, because you're also capturing the human knowledge to build that, that analytics as well, because they may have decades of knowledge working on that particular space. So you're both able to extract it, also you're able to empower and inform them. Okay, great. Thank you so much, both Anil and Sachin. It was a pleasure conversing with you. Thank you very much. Joining us from other part of the world, from Pune in India, to share your insights. Thank you very much.
Thank you, Professor. Thank you.
Today, we have Professor Yogesh Gyanchandani from our own University of Michigan. Professor Gyanchandani is a professor at the Electrical Engineering and Computer Science Department at the University of Michigan. He's also the director of our Center for Wireless Integrated Microsensing and Systems. So he's been leading that center for many years now. Yogesh, thank you very much for taking time from your busy schedule. I really appreciate joining us in this course.
It's my pleasure.
Yogesh, you've been at this technology. You've been working in this sensor technology for multiple decades, and you certainly are one of the leading experts in this field. First, can you tell us about the center that you're leading at the University of Michigan?
Sure. So the center, as you said, is for wireless integrated microsensing and systems. Our charter is to pursue research, development, and application of sensor-enabled microsystems through basic research, through education, and also through interactions with industry. It was created in the year 2000 with support from the National Science Foundation, but we have been operating independently since 2010. And we bring together specialists in a lot of different areas that are relevant to creating the system. And we have a collaborative, multidisciplinary environment with a lot of industrial interaction.
Great, thank you. So, Yogesh, this rich experience for the last 2 decades or more, working with the industry and working on the R&D in the research and development of this technology. Can you tell us some of the trends that you've seen in the last 2 years in the sensor technology, and especially, how it's now being used, in the industrial context?
Sure. First, I want to remind everybody that, even though fundamental research that's done in universities frequently ends up in industry. The path is not always straightforward, and it's not preordained. Funding of academic research is driven by federal priorities established by the peer community through a review process, such as at the National Science Foundation or National Institutes of Health. Solicitations are sometimes driven by professional organizations such as the National Academy of Engineering that sets out grand challenges, and then we try to address some of these grand challenges through solicitations that come out for supporting research. There is also some amount of research that is sponsored by industrial consortia, and typically they will target 2 or 3 nodes, technology nodes out. The federal agencies will try to address more fundamental problems or problems that may be a decade or even 2 decades out. As far as MEMS research and microsystems research is concerned, from an academic point of view, the number of applications is really vast. What we do is we connect the physical, chemical, and biological world to the digital world.
Wonderful. Yogesh, maybe can you explain for our learners, what do you mean by MEMS? What exactly is MEMS?
I should explain that. MEMS is micro electromechanical systems, and it's a terminology that's used for chip scale sensors and actuators. So that would incorporate things like acceleration sensors that are used to deploy airbags, or rate of turn sensors that are used for skid control in automobiles. Mm-hmm. Your cell phone has probably 3 dozen different kinds of MEMS sensors in it.
Okay. So can you give us an example of how is MEMS used in one application in my cell phone, for example?
So in your cell phone, and I'm using the term MEMS more broadly. There might be microsensors that are not necessarily electromechanical. They could be using a different transduction method, but just the microphone into which we're speaking right now.
Yeah, that's a sensor.
It's a sensor, right? And the facial recognition that allows you to access your phone, well, that's actually involves multiple sensors, or multiple micro transducers, as we would say. And just the inertial sensors that tell the cell phone which orientation you're holding it. Those are just, and of course the camera itself is another sensor.
Those are the microsensors.
Those are some of the microsensors, right? There's a lot of other things, right? So, and we can get into that later. But basically, these technologies, in a fundamental sense, can apply in a lot of different contexts: weather forecasting, environmental monitoring, wearable and implantable technologies, for biomedical devices, health and fitness devices. Then there's homeland security and defense applications, things like chemical sensors, communication systems, micro antennas and the like. Transportation systems obviously use them. Smart homes would use them. There's potentially a lot of applications in aircraft and space probes, and of course in manufacturing and adaptive manufacturing. Any place where you would need to digitize a physical, chemical, or biological signal, right? The analog world around us does not behave digitally. You have to be able to convert that those parameters into digital form, and also go the other way to effectuate a change.
Great. Can you give us a manufacturing example, maybe specifically, especially the usage of MEMS in manufacturing?
A lot of manufacturing uses robotics, and robots would use sensors to interface with the environment.
Got it.
So, temperature, pressure, these
any
are
movement, computer vision, all these things.
Flow rate.
Right.
Even certain chemical parameters. There may be a lot of other parameters that would be useful depending on the context. Semiconductor manufacturing, in particular, uses closed loop control for a lot of processes, and there sensing is essential. When I say closed loop control, I mean servo control, where you set a manufacturing parameter and you maintain that by sensing, the various conditions and the mass flow rates and so on of the reactant species and adapt to those.
Got it. Thank you.
So going back to the older point that, there's a lot of different areas where MEMS and microsensors can be applied, but not all of them translate to immediate industrial priorities.
Got it.
Okay. So which are those that do? So let me pull up some notes here. Give me a second. So currently, let's say going out to about 2025, the top sectors for industrial use would be consumer, automotive, industrial, medical, defense and aerospace, and telecom.
Okay.
The consumer sector is the largest. It's projected numbers for 2025 are around $11 billion, I think driven a lot by the cell phone market, with a CAGR of around 8%. So $11 billion on the consumer side. But it's not the fastest growing. Probably the fastest growing is telecom. But that's a small base right now. It's it's only a few $100 million at the moment, and maybe it'll get up to $250 million. But it's growing quickly. Automotive has always been one of the mainstays, and that's maybe a couple $1 billion, but with a slow growth rate, around 3%.
Great. That's very, very useful. Thanks, Yogesh. Also, I want to actually ask you, with your deep expertise in the technology, can you give us an idea in the next 3 to 5 years, the future trends in this technology? I remember a conversation that you and I had a couple of years back, like when I remember you're explaining to me that the emergence of the ideas of sensors being put in liquids and, in oil, for example, you can track them. Movement, you talked about a couple of those. So, for our learners, can you tell us, some of the new trends that are coming, what we can expect in the next 3 to 5 years?
The industrial sector, it has maybe a growth rate of around 9% and maybe about a $2 billion market. We have been working for a number of years on sensors for harsh environments. These have potential use in space applications. So that's very exciting, and very fundamental in a sense, but it doesn't drive a large market. But there are similar harsh environments encountered in manufacturing and in mining and oil and gas extraction, where these sensors can be used to diminish the environmental impact. To do things and do exploration and production more smartly. So. We've been working on some of these sensors. There are some major challenges in going into harsh environments, and we've been trying to address those. I think maybe that's one of the things you may recall from our earlier conversations. And another aspect of that is also monitoring water and air quality. So there's a lot of interest in doing that, and we have a big program in that, in air quality monitoring, and we have previously done some work in water quality monitoring. But air quality is, in a sense, even more important because you can control what you drink, but you can't always control what you breathe. That's right. And the importance of this has been, of course, even further underscored by this recent pandemic and the easy transmissibility of viruses. But even if you just look at the non-biological pollutants, particulate matter, you've heard of PM 2.5, PM 10. Particulate matter has a tremendous impact on health. All the developing countries with growing economies have significant problems and reduced life expectancy and a tremendous amount of lung disease associated with this. And then there's also the invisible volatile organic compounds that you have to worry about. In the West and in a lot of the more developed countries, the attention has turned to this, although it hasn't quite hit the headlines yet in some of the developing nations. But there are carcinogenic chemicals such as benzene that are associated with gasoline production and refinement and usage that can be and should be monitored. And we've been working on technologies for those, and some of those have been spun out into startup companies.
Great, thank you, Yogesh. So those are fascinating applications, and so if I ask you to kind of see, tell us where are the business impact the most, right now, in terms of the size of the market and also potential business applications for companies, and also it looks like. Would I be right if I say that monitoring air quality may be a very attractive market opportunity?
Yes, I believe so. I do. I believe that it could be very attractive. It's I don't. The numbers are not that big yet because the technologies have not matured, but it's coming. This could be democratized. You can envision a VOC monitor in as many places as you would have a carbon monoxide monitor, which is in every home, right? It could be embedded in a thermostat. And you can go a step beyond. If you look at, say, a subsequent technology node where these can be personal safety monitors. So it would be on your cell phone, or you would be able to wear one. Somebody with compromised health, maybe with asthma or high sensitivity to chemicals, could simply carry one around if the price and performance were appropriate.
That's great. That's fascinating. I mean, I can imagine. So that becomes a personalized application for everybody. They can decide the level of protection that they want, and
right. Well, that whole category is called personal exposure monitoring.
Yeah.
So as an individual goes from home to office, or or to a field site, then they can monitor their cumulative exposure over the day.
Okay, great. Thank you so much. This is very, very useful. Thank you very much, Yogesh.
Sure. I do want to come back to your question about where do you think the impact will be most. So as I mentioned, the biggest market is really in consumer applications right now, driven by cell phones. There, I feel that one of the biggest opportunities is in healthcare and in wellness monitoring. So having sensors that can provide medically relevant information, perhaps not quite as precise as you'd be able to get in a hospital with an expensive dedicated instrument, can serve as a screening tool. And I also feel that there is a lot of potential in other biomedical devices, because this comes from miniaturization, right? This technology is associated with miniaturization. So, one of the benefits is the volume, the smaller volume and the lower power it takes. Another benefit is the cost, right? So the automotive industry is using these sensors not because they need the size advantage. It's in most cases it's because the cost of ownership is lower as a consequence of having these sensors. The consumer industry, cell phones and so on, are using it maybe in some combination of size and cost. And they certainly wouldn't be using it if the cost wasn't low enough.
That's right.
Okay. But one of the places where the size is really the prime driver is implantable biomedical applications.
Implantable biomedical, got it. Okay. Yeah.
Right. So if you had if you had to put a pressure sensor in a blood vessel, you simply wouldn't go there. You simply wouldn't do it if it wasn't small enough. And the cost is only a secondary consideration because the cost of implanting the sensor is much higher than the cost of whatever the cost of the sensor.
So Yogesh, do you think in the future trends of 3 to 5 years that we may actually go there in terms of where miniaturization will lead us to putting sensors in blood vessels to monitor the pressure and things like that?
Absolutely. It's not just pressure. It's also other parameters, right? So one of the things that our center has been pursuing for the past decade and a half are pressure sensors that could go and other types of sensors that could go inside a stent or inside a blood vessel. And what we've been pursuing for twice as long, going back to the 80s, is sensors that can go into the neural cortex. At the moment, they're still research tools, but you can imagine the diagnostic and therapeutic applications of brain probes, right? And there's been some commercial activity there as well.
That's amazing. I can see business applications of that too, right? I mean, in terms of understanding consumers, how they think, and all the stuff is there. I mean, because there is a lot of work in cognitive marketing, they call, where you try to kind of, instead of asking questions, they actually try to see what the brain changes, in terms of as consumers react to that.
Yeah, but I don't think we'll get to the point that somebody is going to accept an invasive probe for business. For business. It's a tool of last.
They may accept it for saving their life, but not for a business reason. That's right.
Exactly.
Fair enough. But this conversation has been fascinating. So thank you very much. It has been so helpful.
My pleasure. Yeah.
I'm sure it is very informative. Today we have Sasan Timuri, who's the CEO of Omniscent, who's joining us for a conversation on some exciting technologies that they have implemented using sensors that we've been talking about in the class. Sasan, first, welcome to the course.
Thank you. Hello. Hello to everyone.
Sasan, you certainly, of course, are an alum of the University of Michigan, and the story of Omniscent as a company started here in one of the research labs, correct?
Correct.
So tell us, first of all, of course, go blue, and welcome back virtually to Ann Arbor. Tell us about the journey of Omniscent, how it started, what is about the company.
Sure. Back in 2016, I was designing the storage for supercomputers and building the fastest storage in the world for many Fortune 500, Fortune 100 companies. And I wanted to do something different that I could see impact the world, the health, the world, and so forth. And in one of the meetings that University of Michigan had, webinars or conferences University of Michigan had in Silicon Valley, I met Professor Yogesh Gechandani, who's the director of the WIMS lab at University of Michigan. And I asked him, what is the most mature technology that you are excited about and you think there's a chance for commercialization? And he mentioned that this micro GC, micro gas chromatograph chip that they have developed for the last 10 years is a very ripe technology and could be used. So that was the start of the company. And I was very excited to see that the smallest footprint, what they can do. And I took on myself to go and spend 6 months talking to different customers, regulatories, other customers, commercial customers, and to see what the response is. The response was very positive. I talked to CARB, which is the California Air Resource Board, which regulates the gas industries and pollutant and so forth. In California, they're very prominent part of the government. I talked to one of the executives and I showed him what we have. And he said, where have you guys been? This technology is so advanced that we could use it like yesterday. So those were the very encouragement from the industry. And we decided to go raise some money and build the technology and commercialize it. And that's what the journey started. We raised some fund. We started hiring some talents. And we had a tie with the University of Michigan, which was very helpful, and we started the whole company.
Great. So this is, of course, the MEMS Center headed by Professor Yogesh Gechandani is very well known, at the University of Michigan. And in fact, the university is very famous for that center and that work. So this technology, it's so exciting to hear the technology actually came out of the university's work. And you mentioned about GC sensors, primarily a sensor technology. Can you explain what that GC, can you explain for our learners, what exactly does it mean? Yeah.
Sure. Gas chromatography is a technology that has been around for the last 30, 40 years, and that technology is used to detect different type of gases, and it still is very, very used in industry today, starting from food industry to healthcare to oil and gas. You name it. When you want to analyze a compound in gaseous format or liquid format to see what kind of compounds exist in that particular sample, you use gas chromatography. And then what it is that basically you inject the sample, you collect the sample, you inject the heat or excite the sample so that in a gaseous format, the compounds start moving in the columns, so-called. These are the U-shaped structures that the sample moves based on the molecular weight of the sample. Some of the compounds fall behind, some of them come earlier. From the time that you inject the heat or you excite the sample to the time that you detect at the end of the columns, that's called retention time. Based on retention time, you can tell what kind of compounds you have. Now, the thing exciting about the University of Michigan development was that they shrunk this huge machine, that's a table-sized machine, into a little chip that's no more than 5 centimeters on the side. And that by itself they also integrated pre-concentrator where you collect the sample, all in one chip. And that was quite exciting and very advanced. And I felt that this is the really leading edge of the technology, should be commercialized. And I was right. The type of customers we have is just certifies that point.
So if I understand correctly, so this chip that is being developed at the University of Michigan, we can understand this is a very sophisticated sensor, which is complex and actually basically analyzes the gases through gas chromatography and then identifies the compounds that are there in the gas, right?
Right.
Great.
Right.
So fantastic. I mean, this is exciting. So with just the sensor technology, there is an invention at the University of Michigan, right? Then you kind of found this company, Omniscient. Now, tell us about Omniscient as a company, as a business. What do you do? What services do you offer?
Right. So we wanted to make the product. The heart of this sensor technology is what we licensed or we got from University of Michigan. But what we did, we built autonomous feature around this sensor where we have basically, if you look at our analyzer, it has no buttons, no switches, no levers, nothing. It just wakes up, connects to the portal through the internet, and basically from your laptop or your phone, you could control and start the experiment or the measurement and then get the results right away. So we merged this sensor with the cloud technology in a broader picture. And there's a lot of advancements we made during the way where the information gets transferred to the portal, it gets backed up there. If for any reason internet gets disconnected, we store the data, continue collecting data, store it, and then transfer it. On top of it, we build some warning systems because where this device goes, the people using this device, they want to know if there are pollutants in the air. There is an emission that they didn't know about it, unwanted emission. They want to know that. So we have a lot of warnings that the portals generate. They send text, they send email to command centers, and they warn them that, hey, we're detecting benzene, for example, which is very carcinogenic material regulated by EPA. And once they detect that, the command center needs to come out and take actions to contain that emission. So that's the company in a nutshell. We brought IoT technology. We took the sensor from University of Michigan, combined it, and we applied it to different fields of the industry, and that's the product and journey.
Great. So you have these products that are actually kind of sensing the gases in your customer premises. They're all connected back to your cloud platform, where they kind of have a common place where you can analyze, monitor the data, and also you can raise some warning signals and things like that based on the wonderful. Exactly. Yeah. So this is exciting. What kind of customers, for example, can you give us some examples of your customers, say, in the manufacturing industries or other industries?
Sure. One of the things that comes to my mind, which we're engaged right now, is the oil and gas refineries. EPA has passed a ruling back in 2015. They regulated the benzene at the refinery's boundary. You're supposed to read 3 parts per billion or less. If you're reading benzene at the refinery's boundary at above 3 parts per billion, that means you're violating this rule. So a lot of these refineries started monitoring the benzene at their perimeters and reported to EPA. They're supposed to report to EPA during the thing. So one of our customers has a refinery in Corpus Christi that has a 2 refineries next to each other, and there is an emission of benzene. They don't know who is responsible for it, and there is a big fine if they get pointed to. If there's a proven that they're violating, they're going to have to pay fine. So what they do, they use our product as a production. They put it on their facility. The product works 24/7, and as the level of the benzene rises, or we report that there's a violation, they look at the direction of the wind. We have a wind sensor that tells the speed of the wind and the direction, and based on that, they figure out where the emission is coming from. And in some cases, lately, that showed that benzene coming from the adjacent refinery, not from them. That was one instance. The other instance was that there's a truck came in that was leaking, and parked there, and they were doing some work, and immediately the benzene level went up. They got warning. They went out there and detected, and they told the truck to move it out because it's causing trouble. So this is a production example. Or one of our big customers, the Dow Chemical in Midland, Michigan. They use this one as at their many areas that they have applications. Like one of them is on a shipping and receiving dock. There could be a lot of spillage of a toluene, which is another VOCs. And they use this device to detect that and take steps to remedy the situation.
Yeah, I can understand. I mean, I can see that Dow Chemicals is one of the largest chemicals manufacturer, and they will immediately find this very, very useful. In fact, even for general manufacturers, I think this can be a great safety device. Like, if there is any other any leak or any place, they can actually put this as
anybody that has a VOC in their premises, like VOC stands for volatile organic compound, like benzene, toluene, xylene, styrene, methyl, and so forth. These compounds used abundantly in large quantities in different manufacturing around the world, and people want to take actions to make sure that they don't escape, they don't have emission, they don't have a leak. So our device can go there and autonomously report this situation.
And this is pretty exciting and relevant to what we've been talking about in the class about the applications of sensor technologies. So, Sasan, one last question before we end. So, where do you see the future of these technologies in terms of what are the potential applications, and where do you see the market? Which industries, especially next 2-3 years?
Yeah, so the immediate use right now is the oil and gas industry, wastewater management, industrial wastewater management, and that's a big field. Dow Chemical is obviously involved in that. Any manufacturing facility that deals with these VOCs, they could use this technology. The next one that we've seen coming up pretty hot is that healthcare, medical. There's a lot of work has been done in England and in Europe and some in US that they monitor patients' breath. They call breath biopsy. And they look at the VOC content of the breath. And based on that, they decide this is the onset of tuberculosis, this is the onset of lung cancer, breast cancer, GI problems, and many other diseases. These are proven records and technology that have been published. And so, but we have not done any work on that area, but our device can be used in that front. Lately, we are part of a proposal to NIH for $4 million where they're looking for a skin wearable VOC analyzer where they could read the patient's or the person's VOCs are getting emitted from their skin. And based on that, they could decide this is a certain diseases that the person could have. That's where the grant is. So the medical, healthcare and medical is definitely heading that way of the VOCs, and they're using VOC detection as a means to decide what kind of a health condition is happening with the person.
Great. Thank you very much, Sasan. I mean, this is very, very useful. And really thank you for your time. And,
thank you.
Yeah. Let's go back to the learning objectives that we started with and then revisit the content that we covered in the course. We started with understanding what is IIoT and then what is Internet of Things. That's how we started, from Internet to Internet of Things, and understanding, how this, connecting these things or devices to the network actually, leads to enormous potential for application in the context of business and manufacturing. And then we talked about the building blocks of this technology, starting, understanding the simple sensor technologies, as examples of thermostat, and then starting with a simple thermostat, how you bring, the cloud computing capabilities. We refer to the new cloud architecture and the edge architecture, what the combined intelligence that they bring together. And when you kind of connect these devices into those capabilities, then it gives a special, opportunity for companies to access the data and the insights, ubiquitously from wherever they are. And that leads to a lot of information and a lot of contextual insights that can be converted into business value. We talked about various dimensions of business value benefit that can come in the manufacturing context from these IIoT applications. And then we went through about 5 dimensions of that, and there's a lot more, including making the manufacturer more green and environmentally sustainable. We went through a 6-step implementation framework for managers to understand that what kind of challenges they may face and what are the do's and don'ts and what steps they need to take to make sure that they have identified the problems right, and they've made the choice of the problems right, and they kind of have the right executive sponsors, right partner ecosystem, both internal, external, understanding the compatibility issues to make sure that it works with the kind of infrastructure they have, and finally execution and putting the change management process in place with all the leadership support. And we then moved on to discuss these challenges, critical challenges, and the risks that comes with this technology. And we kind of amplified some of the risks like cybersecurity and the risk coming from cost, 2 sides of it, and also risk from the talent also, both challenges and risk, because this requires nurturing new talent, nurturing new approach to building talent and understanding the new capabilities. We covered some of those aspects more in depth. And finally, last, we spent some time understanding the future trends in this technology and what we can expect going forward in the next 3 to 5 years as they kind of emerge and redefine the future of manufacturing.